Hi, my name is Bob Greenyer and I'm a volunteer with the Martin Fleischmann Memorial Project, so thank you for patiently waiting for me this evening. I got a little bit distracted earlier and I have some problems with my audio. This might not be as clear as normal, but I called it quits a few moments ago and therefore you're going to have to live with this. I am recording this separately on my phone, so hopefully I can merge and do a edit that will have clearer audio. But can you hear me? Like I say, sorry, my Rode microphone is not working. I don't know why, and that's what we have. So can you hear me first? On this 12th of June 2022, when we will be discussing O-Day, light and leptons, clustering of fractal electromagnetic toroids leading to vacuum decay of matter. Okay. All right, you can hear. Okay, so it's not so perfect today, but there we have it. So what I'm going to do is, this might be a little bit windy for those that don't want to listen to windy. That's okay, I understand. We're going to go over some papers that I've looked at in the past, and also some evidence that I should have got into a presentation but didn't for various reasons. And so we're going to have to dig those things out on the fly. But I just kind of want to get this out there now because I think we're at a turning point. So in the work of Takaaki Matsumoto, we have seen that he says that nuclear matter can be completely collapsed, which means baryonic decay. In the work of Holmlid, he is saying that baryonic matter can be destroyed. In the work of Solin, he is saying in his 1992 patent that you can have baryonic decay, and so forth. And what we are going to look at today, so I've spoken about a Japanese person, Takaaki Matsumoto, in the early 1990s, mid-1990s. I'm talking about Solin from the early 1990s. What I'm going to talk about today is something that I was pointed to by one reader of my blog, remoteview.icu, and I would have his name credited, but I will credit it in the blog afterwards because I can't recall right now who it was, so thank you for that. But anyway, he sent me this link and he said, does this look something similar to what Zverblis and Nevesky were talking about? And I think it's right, it does, but what it shows is that the US Department of Energy, through grant funding of individuals and groups, were looking along the same lines. I don't think they got so far and as early, and it is interesting about the timing of this, and we will look at that in a minute. But before we go into that, I want to talk about the organization of exotic vacuum objects in the form of these multiple toroidal structures that can then, it would seem, cluster into macro clusters of a number of different shapes, and the evidence for that, and a kind of model of what that would look like, and how that would then lead to this baryon decay. Okay, and I've said for many, many moons that I believed that this system would be able to convert matter into light and leptons. And light obviously is photonic energy, and it seems to mostly want to convert it into visible and thermal light. And so there must be a means by which it can down sample or down frequency shift light from, for instance, gamma and X-rays that you would expect from normal nuclear reactions into photons in the optical and thermal range and so forth. And leptons can be charged leptons and uncharged leptons. So a charged lepton example would be an electron, and the uncharged lepton would be something like a electron neutrino, something like that. So, but there are a whole family of charged and uncharged leptons. But I'm saying that baryonic matter is able to be converted and basically disassembled into light and leptons. And I believe that this is occurring via vacuum decay of matter. And to get one thing off the table here, I'm not talking about that which was proposed by looking at recent thinking on the Higgs field by Axel, where I think there's a Canadian or a US professor, and he's talking that if you had a structure such, let's say, this structure that we've got here, and it was able to, inside it, increase the Higgs field 2 or 3-fold from its normal sort of strength, then the nucleons, the binding of the nucleus would exceed the binding between electrons and protons, and so the nuclear matter would decay. I'm not going to be talking about that today, but that is an interesting concept. However, what we will be talking about today is something that is intimately linked to a ball lightning, plasmoids, etc. So, before we go on, I'm going to pull up the first presentation. Now, if you go to remoteview.icu and look at the top blog there, the blog on this O-Day light and leptons, for those of you looking at this in the future, I have given the link to the relevant papers that we will be discussing today, and if there are any missing, then I will link those again into the blog for future reference. Okay, so I'm going to switch my mouse to here. Okay, so what we are looking at here is this paper that was published in 2019, but it was received June 29th, 2018 in final form, and this is into, I think it was a major physics journal, but anyway, it is from the National Research Nuclear University, MEPHI, Moscow Engineering Physics Institute, and this is Bogdanovich, Volkov, Len, and Nestorovich. I've referred to this paper many times, but I think it's now the time that we should look at it in a little bit more detail before moving on to other work. Okay, so abstract. The result of observation of plasmoids that were formed during periodic discharge in flow of liquid, in particular water, in its surrounding space during discharge and in post-discharge have been presented. The presence of long-lived luminous formations, not only in the air but also on the surface and above the surface of nearby objects, has been noted. The reason for the appearance of such objects and their properties, which have features not only of macro but also micro objects, such as Dirac's monopole, have been analysed. Okay. So, introduction. The periodic discharge of flow of liquid, PDFL, has been known for more than 20 years, and it has been found application in a number of technologies relating to its modification of properties of metal surfaces. So this is, for instance, ion implantation that was being done by Suhas Ralkar, creating his processing of metals for different treatments, and so it actually modifies the metal surfaces. But why? The schematic diagram of the installation is shown in figure 1. So here we go, we've got our water flow coming down here, we've got the metal target sample, and we are doing discharges with the water flow. The main device supplying the discharge is a hollow metal tip, this one here. Processed material 3 here is located on table 5 here, which can be moved both automatically and manually. Tip 1 is connected to liquid reservoir 7 by dielectric pipeline 8, so this pipeline here, which can be moved both automatically and manually. Tip 1 is, blah blah blah. Tip 1 is supplied with a constant negative potential from power supply 9, so this is different from what Suhas Ralkar was doing. He was doing pulses, and then with a constant voltage of the order of 7,000 volts. Sample 3 with the table 5 are in dielectric chamber 6. The excess liquid is drained through a drain system 4 here. And Suhas also had a drain system. There is periodic discharge 2 here with repetition frequency of 50 to 300 hertz. So this is actually pulsed discharge, I guess. Right, so yeah, this is very similar to what Suhas Ralkar was doing. There was a DC voltage, so that it's always moving forward, and then there was a pulse frequency. Arc discharge, which lasts several tens of nanoseconds pointwise. crater diameter 50 to 20 m, I'm not sure quite what that means, affects the treated surface. I think maybe that's millimeters. The speed of movement of the table varied from 0.25 to 2 millimeters per second. The discharge process leads to disintegration of the continuity of the liquid mass and the appearance of shock waves, which are accompanied by powerful crackle and emissions of part of the substance at remote on the scale of the experiment distance up to 10 centimeters or more. The properties of PDFL as an instrument of physical research have not been fully studied yet. The key to understanding the physical process that accompany the discharge can be analysis of plasma formation, both at the stage of discharge and in the post-discharge period. Photography and filming of the discharge showed that it has two characteristic stages: the discharge on the surface of the liquid jet and pinch discharges, which exist both together with the main discharge and on their own. Spherical plasmoids are observed both in the volume and on the electrode surface in the absence of the main discharge. The glowing filament with a length of up to 1 centimeter, the ends of which are thickened. This is very important. The ends of which are thickened. Why are they thickened? Were discovered. The duration of their existence, as a rule, does not exceed units of seconds. So what they're talking about here is these filaments. Okay, and you can see from up here, there's kind of like an end stop here, and it comes down, and the filament's going all the way down here and round here and down to there. And up here, you can see there's a triangle. It looks a little bit like our usual golden ratio triangle, and it's thickened at the end. This is what they're talking. It's thickened at either end. Okay, so this is a typical filament here. Okay, video and photography of the discharge from a distance of 1 meter or more showed the presence of luminous plasmoids, which leave the discharge region at a speed of more than 25 meters per second. So something like this. Okay, the figure shows 3 clear images of plasmoid, which correspond, in our opinion, to the 3 values of plasma temperature, namely the white image, maximum temperature in the plasma formation in the discharge, blue and red as it cools in air and increases in size when moving. Now, you can't see because they put a black and white image in here. So we've got white, blue, and then red. Okay, and this is actually the same plasmoid that's moving from across the field of view of the camera. Okay, this is shown in other work, and I've shared the other work in the past, so you can see the colours, but unfortunately it's not in this particular reference. The red colour corresponds to wavelengths in the range of this and that. The acceleration of the plasma can be caused by both shock waves at a high current discharge, which are accompanied by a loud sound, and by an electric field at high voltage, at a high voltage electrode up to 7.5 kilowatts. Okay. Recording of long-lived plasma formations. The study of the surface of metallic electrodes that were exposed to PDFL discovered the presence of luminous spot areas on the surface whose illumination has fairly long duration, over 2 days. And we've referenced this in respect of the Verblist claims of the classified bagel research, where they had these vacuum structures existing for 2 days approximately. And also with the Reutzkev work, where it's observing the magnetic fine moment of iron 57 being affected by metal foil like titanium exploded in water and 0.7 of a meter away, changing the fine constant for about 2 days. Constant observation of the surfaces of both exposed to PDFL and located in the zone directly adjacent to the discharge, as well as the zones in direct contact with such surfaces, was completed, which could confirm the assumptions about the existence of stable particles responsible for long-term glow, plasma formation, at the micro and macro levels. In order to clarify the nature of the observed phenomenon and the dynamics of the processes of appearance of luminous zones, the analysis of the obtained data showed the presence of luminous objects moving along the surface. The shape of the objects is presumably toroidal, and the axis of the toroid is parallel to the surface. There are reasons to consider them rotating relative to this axis. The toroids are inhomogeneous along the azimuth, as evidenced by the movement of the darkened sector from left to right and vice versa, which most likely correspond to the rotation of the toroid around its own axis. They have size of 50 micrometers and a speed of more than 10 micrometers per second. The time of their stay in the field of view of the microscope with the video camera is few tens of seconds. The plasmoid emission color is green, which may indicate an air temperature that corresponds to wavelength 5100 to 5500 angstroms. So hold that green thought in mind as we look at this other paper. The dark sectors are not visible on individual objects of this type. According to preliminary estimates, the speed of the rotation of the toroid is on the order of 0.5 revolutions per second. Okay, this is not a lot of revolutions per second, is it? The following was found in the process of monitoring the state of the surface of the transparent dielectric that was located above the surface of the metal plate, previously arranged in close proximity to the PDFL during the formation of pinches. A stream of particles, presumably electrons, which causes air to glow. A similar pattern is observed after the emission of electrons from the electron source, or they're injected through the foil, is emitted from the surface. After 10 to 20 seconds, this stream is formed into a set of several rings, 5 or 6, of the same diameter, which rotate around both their own and common axis parallel to the plane. Figure 7. So we've got this figure 7. Now, is this looking top down, or is this looking at a crystal-like structure? I think it's probably like a crystal-like structure, and they are saying somehow that this is 5 or 6. Well, 1, 2, 3, 4, 5, I don't know, 6, 7, 8, 9, I don't know. I kind of see a little bit more then. This is where it would be very helpful to actually have the video data here. The stream of electrons from dielectric surface and complex object of the type luminous rings that is formed by it, rotating around its own and common axis, rolling on the surface. The whole system begins to rotate around a common axis and moves in a horizontal plane. Then it transforms into an electronic tornado, which rotates around the vertical axis and is almost identical in its shape and size to the pinches in the discharge. The height is a few millimeters, not more than 10. This tornado is removed from the camera and disappears. The whole process lasts about 1 minute from start to finish. The transverse size of the rotating tornado is not more than 5 millimeters. So you've got the scale here, 5 millimeters. The video recording of the interaction of the pinch plasmoids with dielectric surface is no less important and informative. A glowing object in the form of an ellipsoid, which rotates around its axis, hangs above the surface, and in its lower part, which is closest to the surface, forms a prominence elongated towards the surface, which then detaches and passes through the surface. Of particular interest is the presence on the other side of the surface, into which the budding part of the ellipsoid is drawn in. So here we're coming interaction of plasmoid with the dielectric surface, so it's coming in. So maybe this is a piece of glass, and you have this thing coming through, and then it basically sits here. We've got this dielectric surface, it's keeping its distance, but something has gone through to the other side, and we see this weaker luminescent structure visible on the other side of the plate, lower right here. Okay, but notice this distance, and we'll see this distance being discussed elsewhere. And the idea is maybe this is the same kind of structure, but look at the shape of it. It's kind of like, you could imagine this is side on with a toroid, but we've got a glow over the top here. What is this? What is this beam that comes down and then penetrates through this material here? A particular interest is the presence on the other side of the surface into which the budding part of the ellipsoid is drawn in a spherical object, making a movement in space. At first glance, not correlated with the movement of the ellipsoid, but within the video field of view. The dimensions of the ellipsoid and spherical object are 5 to 6 millimeters. The duration of the observation process is about 1 minute. The glowing color is blue. Okay. So this here is, I think, very interesting, because this is showing something that was formerly part of this being attracted to and then passing through a dielectric, and there seems to be still a relationship between these two bodies. The existence of quasi-stationary, although relatively short-lived, luminous plasmoids of spherical and linear configuration was theoretically justified by the authors and their colleagues in the framework of general relativity, with the involvement of the concepts of microgravity and space-time distortion. It was shown that the steady state, in principle, is possible at the corresponding concentration of ions of the substance in the plasmoid volume, in particular at the parameters of pinch discharges in the conducted experiments. Further analysis indicates the expediency of involving the concepts of stationary centers of formation and stabilization of plasmoids. In particular, stable particles of the magnetic dipole type, 6, responsible for the rotation of the plasma formation components, more precisely of dions, type 7. What is a dion? Okay, so let me dig out what they're referring to with 7. So 7 here is Paul Dirac's dions, and that was from his 1931 paper, and that's actually a type of, I think, kind of like a monopole. This is indicated by the presence of luminous thickening at the ends of the thread. So what is it referring to in 6? Or is it 8? Where's 8? Okay, so this is indicated by the presence of luminous thickening at the ends of the thread in the area of discharge localization. The possibility of inclusion of the phenomena under consideration in the field of research is indicated by various researchers, in particular 8. Okay, now what are we talking about here? We're going to have a look at 8. We've gone through 8 before and translated it, but anyway, we're going to have a look at that again. And it's this link here, this light dynamics, narrowed, so on here. So basically it's referring back to the work of Paul Dirac in his kind of like, you have electric charge but also magnetic charge in that 1930s work. The results presented in this paper indicate the need for more thorough study of this factor on the nature of well-known phenomena. The key question is still the occurrence of magnetic monopoles or objects with similar properties in the discharge zone. One explanation for this process can be a recording of the prints that indicate the presence of objects belonging to this type of physical object in the form and properties, in particular their penetration through double envelopes of film projection print type. So here he's talking about the birdies, these classic birdies that I've spoken about in a long time, and they're talking about their work and other people's work in observing these structures. What they're talking about is effectively that they've got monopoles here. You've got a monopole at this end, and you've got a monopole down here, and this is a flux string between the two, magnetic flux string. Okay? So this is a very macro object here. In accordance with modern concepts 8, and we're going to look at that paper again, electrons can form Cooper pairs in the field of a monopole and rotate tending towards it, but at the same time losing energy in the near zone to it. A halo of electrons and atoms of ionized air can be formed around the monopole. The total magnetic field together with the plume field can be interpreted as the dipole field. So you actually have a monopole type structure that creates something that looks a bit like a dipole in the outer zone, of which electrons can exist stably, including those in quantum state and ultra low temperature, and form structures identical to those in figure 7, which is this structure. So they are specifically saying here that the in the outer zone of which electrons can exist stably, including those in quantum state at ultra low temperature, and form structures identical to those in figure 7. Okay. So I have said for a long time that this cold electricity, you get this condensation, this thermal energy that comes out, and the electrons must effectively cool. They are basically no temperatures at all. And when these structures blow up, the electrons return to their normal type of state, they then coulombically repel each other. You get this spherically expanding explosion from the coulombic explosion, and it produces this EMP because you've got a charged particle moving over a distance, a vast number of charged particles moving over a distance, all in a spherical way. But you also have the electrons going from their ultra cold state to wanting to get their thermal energy back, and this means that it freezes things instantaneously. This was observed with Lion. It was observed with I believe in the second video that I shared, Evo Blaster from the Henk Uren Vega Valley reactor. So that you saw these black spots appearing. You saw this bright white flash, and then you saw this black spot that would then slowly warm up and return to the same kind of glow as the rest of the chamber. And I believe that there's a researcher out there, I think maybe I haven't showed the video, but I'll dig it up, where they've got a spark gap, and it's got some Tesla coil or whatever, and they've got the spark gap, and by getting the spark gap at the right distance, you can end up even in air by forming ice crystals on the anode. And so I believe that the clusters are forming, they're releasing their heat, and when they hit the anode, they're grabbing all that thermal energy back. Okay, and so this is your cold electricity. Okay, so they are talking about the fact that these clusters form and that they have the electrons in this quantum state at ultra low temperature and forming structures identical to shown above. Rotation around the common axis resembles the dynamics of electrons in Earth's magnetic field, gradient drift, etc. Analysis of the obtained results clearly indicates such properties of the observed objects and phenomena as the presence of superfluidity, ability to form objects with clearly fixed dimensions, and rotation of objects as a whole and in separate parts. It is the magnetic monopoles or dions, so magnetic monopoles, as I will show in this thing 8, or the dions as according to Paul Dirac, which are accompanied by a plume of Cooper pairs, can create magnetic fields of dipole configuration, okay, in which the electrons of the outer shell form electronic rings of the same size due to the quantum nature of the magnetic flux, in which the electrons of the outer shell form electronic rings of the same size due to the quantum nature of magnetic flux. Are they talking about these toroids that we see? The results of the penetration of the plasmoid through the dielectric barrier can be explained by the fact that the electronic plume follows the monopole, or more precisely by a cluster that contains ions, electrons and dions, which presumably penetrates through this barrier. So to penetrate through the barrier, this cluster that contains ions, electrons and, this would suggest, monopoles, the overall structure must be neutral so that it can travel through the matter without interacting with it, okay? Or it's in some structure that is able to pass through the matter, okay? So it doesn't express its charge. So this is very much in line with Ken Shoulder's thinking, and also you will see with the other paper that we're going to be looking at in detail today. So before I move on, I'm just going to dig up this link, and we'll just look at it, but I have looked at it before. Okay, so just give me a second. I have to do this in Chrome so that it'll do a translation of it. So give me a second, I'm nearly there. Okay. Right. So this is the paper. Like I say, I've referred to it many times before. It's by Wisniewski. I think it's from 2008. It is something like that, yeah, maybe. Okay. Okay. Superconductivity of a Dirac monopole. So essentially, the modern theory of low temperature superconductivity is based on the idea of macroscopic quantum state of superconductor, which is convincingly confirmed by the quantization of magnetic flux circulating in a superconducting ring. And it goes on about this, and I've gone through it before, but basically you have this magnetic core, which comes down here. This says magnetic core in Russian. Maybe you can't read that, but that's what it says. And so this is where this material is focusing, and this causes these electrons to self-organize opposite each other, and they orbit down in a cone, and they cohere into Cooper pairs, and this kind of builds the intensity of the structure. And they go down in this spiral, which we witnessed, and in fact it's 2 spirals, and they come in to a fixed radius, and you can see this cone here coming towards the magnetic core, and then they fly out, and if we go and zoom into this area right the way down around the center of this magnetic core, you have the center of the magnetic core here, and these coherent electrons in a ring around the center of this structure. So this is the sort of pseudo monopole structure, and this, as we see in physical manifestations, these come down, and sometimes the electrons come down and they get sprayed out from the side. So you end up with this sort of tail of the bird, and then the 2 sort of wings of the bird, and there's this central zone, which is our kind of magnetic core. So that's it, and he talks about the derivation here and how it all comes to pass and so forth, and the constants there. Okay, so that's that. Okay. So for Join the Technicians, what did you miss? You missed a lot of me having problems with audio. That's why I've got terrible audio today, and late starts. You didn't miss too much. But I've just gone over the Bogdanovich paper, where we saw these long-lived plasmoid structures, these crystal-like structures forming of it, and the fact that you have these monopoles at the end of these strings, and you can imagine one's north and one's south, and that's why you get the thickening at the end of these strings. And there's other plasmoids that they observed, but one of the key takeaways here is this ultra cold, ultra low temperature electrons that are formed and into these structures. Okay, and it's superconducting and superfluid. Okay. So, okay, so I've got 2 ways I can go here, but I think the way I'm going to go right now is to talk about structure and how we got there. And so what I'm talking about is this organization here on the right. And why have I organized it in that way? Well, firstly, this is a dodecahedron. It's a 12-sided structure, and this is one of the platonic solids, and I like this platonic solid because the alchemists use this to represent the ether. And so if you can imagine that we've got this vortex cone going into the center here, that it's focusing material all to a central point in this structure, and if it's pulling material in and spraying it out and these are bound together, then it's just churning more and more material into the inside of this structure. And so it's like a confinement structure. Anyway, I'm going to talk about how if we take 3 of these sections, we can get to something that looks like this. I have some imagery, and I would have put it into a series of slides. If I can find it quickly, I will. If I can't, then I'll put it into the presentation later. I've been working on it all week, but we'll see if I can actually get these for you relatively quickly. Okay, so if you just give me a few minutes, I'm going to pull up this structure, or my discussion points on it, rather, shall I say. Okay, so, oh dear. What have I got to show you that is actually the ones that I wanted to show you? Look at any of them here. Okay. So this is just terrible. This is just like the worst ever presentation. What I will do is I'll just run over these quick, and you just have to take my word for it. And then if I can find the material at the end of the presentation, then I will, because I want to get through the paper, and we had a late start because I want to talk about the baryon decay and how the Americans with US Department of Energy were hot on the trail of this in the 1990s. And if not, they should have been. Okay, so I'm going to call this points to understanding. That's just the slide that I've just typed in now. So the first point that I want to make, for those that have been with us a long time, you'll know what I'm talking about. For those that haven't, then I'm sorry, but all the material is published. So the first one is the flux loops and scallops on 2017 lines. So the scallops I recently showed, but also the flux loops where we had these interacting with X-rays, but also we've most recently seen these actual physical flux loops, not just the things that were producing them, but a whole flux loop. Then I think it was in a video I called Magic Incarnate, looking at the Hutchison fracture sample, there was a flux loop that went across a valley, and it kind of met in the middle, and material was coming out of the center point, and I call this like coronal rain, and elements were being synthesized at this collision point, the sort of halfway point, and it was coming down and it was forming this material. So this is again a flux loop. The vortex hole also on the 2007 fracture sample, and where on the edge of the vortex hole there was this flat land, this kind of like plate, this plateau, and it had these interfering waves of different elements being synthesized, and so you kind of like there's magnesium and silicon and carbon and anyway, we might pull those up. These two are both in Magic Incarnate, so if you want to go and look at that video at another point. The Hutchison 1986 ball burn sample, so this had a spherical thing in the center of this birdie structure. So just like I was talking with in the Wisniewski work there, you have the birdie with the tail, and in the center of that you have the sphere. This is where I believe the magnetic core is, and around that structure you have these scallops, and in the scallops you have substructures and so on. So that for me tells a lot of what's necessary in this story, that 1986 ball burn sample. And then the Hutchison 2007 knee sample, if you remember, there's this golden ratio type triangle, and along the outside we saw a couple of these hexagonal toroidal type structures, but on the bulk of it we saw all of these scallop sections. We saw the scallops on the Amaza gas-treated 10 yen coin, again these kind of scooped out areas around the periphery of the rotation of the ball lightning, or rather the material that's rotated around the ball lightning structure. And then most recently the scallops where they're very, very well defined, and you had these on the cut line with the ball lightning in the Vega 2021 copper pipe ball burn sample. On the edge you had these kind of round holes, but actually one of the clear ones was like an octagonal structure, and in there you had material that was being disrupted in micron kind of divisions, and you can see that it's going away, and there's one in this orientation, then there's one separately in this orientation, then there's another one in this orientation, then there's another one in this orientation, and so on. So you can see this kind of like there's alternating orientation going on. So we kind of just derived a kind of sort of structure from that, and using that, I'm going to show something with you if I can, and then we will talk about the second paper that I want to talk about tonight and how that gets us a long way towards nucleon decay, okay, from these type of structures. Okay, so what do I want to show you next? Okay. So when I'm showing you what I'm showing you in a second, I want you to hold these things in mind. So you have these toroidal structures. Okay, and these toroidal structures can form into these kind of structures, okay, which are groups of them, and that the original toroidal structure itself is, according to Bogdanovich and those at the Moscow Nuclear Physics Institute, possibly caused by a magnetic core that has a plume of cohering electrons that are coming into it, and this toroidal core, and then it has the kind of material that's coming out from the outside, and this may or may not produce these toroidal structures which you see glowing here. So that bearing in mind, I need to get something from Lion. Okay, so just give me a second, and you've seen this actually quite recently, and I haven't. Why is that not in? Okay. Why have we not got that? Don't know why that's not there. Having all kinds of problems with. Okay, we got it there now. Okay, so. With me. Okay, so the one I've shown you how these things can cluster many times to the point of it being rather tedious. So here's two, but they are of the same type. They are both, in this case, south, and we have two of the north type here, and we've shown these ad infinitum. But they can also cluster group into larger clusters, and I've shown this. And you can see that they are sweeping material around the outside, and there's this interference zone. So you can see that the size of this torus here, there's the center point, and to draw this torus around, the torus comes into here, and this one comes into here, and I call this the interference zone. But what's actually happening here is these two things are getting closer together, okay, and it's resulting in anyway. The point being is, one could argue that there's a flux loop going between here and here, and this is the material flowing around that flux loop. That stands up to some scrutiny, but then, it doesn't explain how it moves around the outside. So I believe that these are two torus of the same type. The same type, in this case they're north poles because they've got a uneaten center, and they are attracted to each other. So there's some means by which these things can cluster together in groups. And I think one of the most important groupings is this one, where we see 3 north poles grouping together into this trefoil. And why is this important? Because this 3 north pole structures in a trefoil is effectively 1/4 of the structure that we see here. So this one here, and this one here, these could all be north. And as Solin said, you get solitons of 2 types, which we have observed on the Hutchison fracture sample. I call them an innie and an outie. Obviously, the innie is the south and the outie is the north. Okay, and they can cluster together into magnetic charges. And for them to cluster together into magnetic charges, the same type of soliton has to be able to join together in order to form a cluster of the same charge. Okay, so this loop here, this loop here, and this loop here, they are, let's say, in this case, 3 north, and they are joining together. And we know 100% that that can occur because we see it here. This is not something you ever have to do in a calculation for. It's already happened here. Physical evidence saying that. Now, if you've got these 3, you can imagine that those 3 times 4 would make our dodecahedron structure here. Then you would have a spherical magnetic north pole. The opposite of this would be a south, and so therefore you have magnetic charges. Now, these what is the magnetic core of this monopole, the core here that produces this Dirac-like monopole. Okay, it's a magnetic charge. Okay, I don't know. And then these leads to. So is this structure here something? Is it really just on a flat surface, or is there some 3-dimensionality to this? I don't know, but I suspect there might be. So this actually is on a curved surface. So I'm looking through the glass and I'm seeing the damage to the backside of the glass, which is curved. We know it's curved because, well, it's curved, okay? So already what you are seeing here on this screen is curved. It's quite seriously curved. So you can imagine that they would quite possibly be able to curve into something that would form this dodecahedron type structure, which focuses everything to a central point. Okay, right. So that is that. So what I did is I took this structure that you see here, and I assumed that the center is where much of the energy would be, or the material would be focused, because we see that in the ultrasonics of Suhas-Ralkar. The material and things are swept into the center, they come into the core, and then some of them get swept around the outside, and some of them get thrown off to the side. So whilst the actual superconducting superfluid structure is, it's kind of like it isn't rotating, it's moving the material around it. It's a bit weird to think about. So if material is constantly coming in here, and this is where the condensation has to occur, then the energy would be released predominantly from this core. And if you actually look at what is being observed here, it does seem like it's very bright, maybe in the center. You don't see a dark bit in the center here. Now, when it gets very large, you do see some tori potentially that have a hole in the middle, but we've seen those structures separately, most recently in the CU pipe that's been damaged by ball lightning. Okay, so it's a bit of a white blob. It's a white blob here. Okay, so are these south poles in a cluster? Possibly, I don't know. But so what I'm saying is that it's brightest in the middle here. Now I'm going to show what I built is kind of like a simplified structure, and with these tori, and here it is. And I'm going to zoom into this. So this is what you've just seen in this one here, this dodecahedron structure, but instead of using these coils, I've used an analog here, and they look like toroidal marshmallows. I mean, I would like to eat these things. They look pretty tasty, but they are what they are. There are, in fact, I tried to go for 24, but I didn't spend too long thinking about it, so I think there's 26 around here, but it doesn't matter. We can go up to 48, definitely. Okay, so these are the toroids, but it's the center where you've got a large glowy spot. Okay, so if you can imagine, there's this bit which are just spheres, and I've made them like 100% on. Okay, so they are in the central spot like that. Now, if you have both of them in play, you end up with something like this. Okay, so we've got a lot of glowiness in the center here, and with our toroid around the outside, with its ability to colloidally move matter and toroidally move matter. Okay, and then if we combine these and give them a bit of glow, we end up like with something like this. So this is like they are ionizing some air around them. So rather than just being the physical structures here, they're ionizing the air around them. Okay, and then if we distort them a little bit, because they talk about this elliptical distortion that's going on in the Bogdanovich paper, we end up with something like this. Okay, now does this look a bit like this? Does it? I don't know. But what I'm saying is that we can cluster these things. We know we can cluster these things because we've seen it in the Lion reactor. Where is that? It is here. It is here. Where is it? It's here. We've got a cluster of 3 here. Okay? And this 3 here is like 1, 2, 3. Okay? Interestingly, when you have this model where you have this central toroid and this lump in the center, you end up with something that looks pretty similar to, where is it? Down here. Look, it looks a little bit like that, doesn't it? So, not there. Oh, it's a bit messy, but you end up with this toroidal structure here with this sphere, yeah. And it does look to me, I don't know whether it does to you, but this central bit is glowing more than the toroidal around the outside. Does that look true to you? I don't know. But you can see my center here is glowing a little bit more than the outside. Okay, so this is a kind of model for a crystal-like structure. And as I say, we know 100% we can group these toroids of the same type together. Okay, this is 1/4 of this dodecahedral structure. And is this similar to this? I don't know. If I made the toroids smaller and there was a bigger gap between them, then maybe it would look more like that, and I can explore that in a future attempt at replicating what we observe, or what Bogdanovich may have observed here. I would really like for him to share the video so that this can be made clear. Okay, does that make sense? Does that make sense? Yeah, it's a bit like a sand dollar, Corky. Hi Henk, great to have you here. Okay, interesting finding, Henk. Okay, he says. Right, now, I will credit the person in the blog. I lost a lot of time today, but anyway, let's not dwell on that. What I'm about to show you, I only read for the very first time yesterday. It was a previous reference to a paper that I will share afterwards, which I was linked to a couple of days ago. But the comments in there and its correlation with so much of the last 4 or 5 years is quite spooky. It was written in 1994. And if you remember, around 1993, Matsumoto started talking about ball lightning being the cause of this electronuclear collapse process, which can lead to the decay of baryons. And he started talking about this, and then the rules were changed for the American Nuclear Society's Fusion Technology Journal, which meant he could not publish his work. He protested in a typically Japanese reserved fashion, but that came to no avail. You had to have tritium, you had to have neutrons, and you had to have gamma rays. All of the things you shouldn't expect out of what I'm calling a coherent matter reaction. And so that's the problem you had there. Now, the paper is going to be 1994. It was published in October 1994. Another paper, and it's funded by the US Department of Energy, at least in part. The second thing that happened in October of that year, the US Air Force, the J.R. Roth paper, which I've discussed before, was submitted to Fusion Technology, and it was published in May, I think the 15th, or in May 1995, saying that if you made a 10mm ball lightning, it could provide all of the energy for, say, a house or whatever. If only you could do it. Well, that has been achieved, I believe, in the Vega Valley. It consumed that copper pipe. It's of that order, and in fact it's not the only one, and therefore the process has been achieved. And we're going to talk today about how something which will blow your mind, it will blow your mind, because it's exactly what we've been talking about, could lead to vacuum decay of nuclei, and that this would lead to a current source. This would lead to a current source. This would lead you with a lot of electrons with nowhere to go. And so you'd have to ground them in order to be able to create a charge path such that you could drive electronic components. Okay, so it's a current source. Okay, why is it current source? Because you are decaying the baryons into light and leptons. And so you have all these, some of the leptons are uncharged, they fly away. Some of the light is just light, so that goes away. But the abundance of negatively charged particles are then need somewhere to go, so they like to find ground. Okay, so you need to put it through things, and this is why I believe the PAC device failed when Feynman pulled the thin cord out of the wall. The cord to the wall was basically a ground for the build-up of any leptons that might build up otherwise in the metal. Okay, because he pulled it out, the metal failed. Okay, so what you're going to see is something very, very consistent. So just to recap, I believe that the line reactor shows that you can cluster these solitons, which were clearly identified by Ken Shoulders and by Bostic before him, but that you see the precise aggregation here on a curved surface, and that this is 1/4 of a dodecahedron, which is the structure of the ether according to the alchemists. And I believe that this is a kind of good model for a basic ball lightning structure, and it's here, over here. Okay, so I'm just going to go and show you a bit around this 3D model and something else that I've been thinking about. This might break my computer, so let's see if this works. And you can see into the 3D model. Right, so I'm going to have to move a few things around here. Don't go away. Are they going to get very interesting or silly? Okay, so I need to go here. I'm going to look at your comments whilst this is loading up. Corky, I always get a feeling Bob has something up his sleeve every damn time. You're not wrong. Oh dear. Oh, so funny. It's why I shifted to live and dirty presentations, because the more I worked, the further out the what I'd shared became. So I'm trying to push it as fast as I can back to real time, but it's always a struggle, and I've still got a backlog of things that I need to deal with, and it's frustrating. But I want to maximize the ability of everyone to know in their minds with utter certainty that this is a reality. This is vacuum engineering. I mean, it is. There's nothing beyond this. I mean, it's not hyperbole. It is not hyperbole. There is nothing that anyone, anything, any sentient being on any part of this universe, in our particular bubble, will find that is more the root level of how everything works. I've mentioned Edward Leeds Scarlin, and in fact, in his book, A Book in Every Home, it was funny because I'd made this conclusion that you had these two types of structures that would force in and make a yin-yang, and that's actually in the inside cover of his book. So Edward Leeds Scarlin knew this technology or aspects of it. I think that's pretty sure, pretty certain. Okay. Okay. So I don't know whether I need to go into model for this. I'm going to see if I can do this without breaking my computer. Let's see. Oh no, it's the wrong resolution, isn't it? Oh dear. Give me a second, I've just got to scale this. Real time laying out the screen. Oh dear, terrible. Okay, I'll lock that so things don't break. Okay, so here we go. Maybe not. Give me a few seconds, nearly there. Okay. Right. Okay. So here's our dodecahedron, honest. When I show you, it will be. Can you see it? Can you see it? Yeah, okay, you can see it now, I think. So this is our dodecahedron here. So you can see it there. It's very shiny. And then I have the surface structures here, which I'm going to turn on. And so you can see them here. And the reason I put the dodecahedron in the render in the background there is it's easier for the mind to be able to separate out the structure here. But if I actually group these things together, this will work better when I do this. Okay, all right. So if I go, maybe I can rotate this. Oh, that's not in the center object. Oh dear. Okay. All right. Well, if I rotate this, it's going to rotate a bit wonky. But so you can see the top here with our 5 things going around the surface here. Okay, so. And if I rotate it around here, you can see. Okay, so you get the idea. If I actually kill the dodecahedron here, it starts to become a little bit confusing because you have this big nest of material. But you can imagine that if you're in the center here, as I'm going into the center, that there's this lovely kind of void area in the center here. Okay, which is the center of our, let's say, our hollow sphere. Okay. Now, the question is, can we? What I've got here, if I put back the dodecahedron here, what we've got here is these are 1, 2, 3 tors. Okay. Do we need 1, 2, 3, 4 tors? Don't know. This would create the Poynting vectors in the vacuum. So maybe not. But if we were going to do 1, 2, 3, 4 tors, then that would... How those are particularly configured is a little bit a mystery. But it is a magnetic core that we are trying to achieve. So the odd fractal structures, so a third level tor, has a magnetic field, supposedly, that it will generate. And so that's kind of what you would want to create a north or a south magnetic core. So I think odd level tors would be the right way to go. Now the question is, should we have more odd level tors, and can they form this kind of structure here? Now, this is going to look a little bit wonky in people's minds when it's actually done the mesh. And so this is, for every single tor here, we have 5 tors going through the center of it. Okay, well, it's actually, you have 12 on the main structure, and then you've got 5 on the top and 5 on the bottom, so that's another 10, so that's 22, and then you have another 10 around the rim. Okay, and I think, do you have 10 around the rim? I think maybe you don't. Maybe it's 22. Okay, but you end up with this ball structure. Now, is this the structure? I don't know. But this does have this kind of woven thing to it. Now, I've got some unbelievably beautiful renders, which I will try and dig up on the other computer to see, because it becomes very difficult to see like this. and you can imagine that if I get rid of the dodecahedron here, you're not going to have a hope in hell of working out what's going on. But believe me, there is a hollow bit in the middle of there where our nucleons could live, or our dead space can live. Okay? And it has these central areas where matter is kind of like focused. And this is what I was talking about, those white spots. So the white spot would be in the center because things are being focused into the center. Yeah? Either by the torus alone or by this overall structure. And these are kind of like your magnetic flux loops. And we see these kind of curved sections on the inside of the torus, on the split torus impact in Henk Uren's Vega Valley copper ball burn sample, and also on the broken sphere from Alan Goldwater from the Ultra experiment. Okay, so I'm not averse to it actually being something looking like this. Now I'm gonna show you some more beautiful images, and I'll switch back to killing this because this is a lot of drain on my computer here, and I don't want this to crash halfway through this presentation. So I'm going to go back to my mugshot here, and I'm going to kill this one which we've got here, and I'm going to go back to there, and I'm going to, how should we do this? I'm going to kill that. And that will help. So speaker. Okay, there we go. Right, now I'm going to go kill Lightwave. We're not going to review that because it's a bit clumsy to do that. Okay. And it's slowly closing that down. Okay, all right. Whilst it's doing that, I will find the other renders of that so you can see beautiful images. Talk amongst yourselves. Okay, so here we go. This is our basic dodecahedron structure in the center there. And we can zoom into that, I think, maybe, so we can see it here. Right, there we go. All right. And then if we look at just the mesh only, there we go, you can see. So you can see there's a big hollow space there. You actually get toys that are a bit like this. Okay. Combining the two, we get something like this, which is a little bit easier to see, as I've shown you in the cover slide. So this is actually part of the cover slide of our presentation today. If I take out if I add in the full structure here, it gets a little bit complicated. So you can see here. So you can see for this one here, you've got 1, 2, 3, 4, 5, and they bind together this. But I believe they can, as we've seen in the, Lion reactor, it doesn't need these things here. And if we look at this, it's just a little bit of a lot of wire. I'd hate to try and untangle this, let's put it that way. I've actually got all the lead wires here. So it's either this structure or this structure, either with a 3 or a 4 tor, that I would like to see if experimenters could investigate by putting timepieces in the center of here, by putting radioactive isotopes in the center of here, by putting plants in the center of here, by putting masses like bismuth in the center of here and energizing it. But the first thing we need to identify is the right, correct, left, left, right, right, left, right, 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 or whatever, for creating the opposite pole structures. And that's difficult when you're doing alternating current, but anyway. But those ones that have one effect in one of these areas will have an effect in all of them. And then you have this structure here. So that is basically a squished version of this. Okay. Right, so now we're going to go on to the second paper. I'll have a quick look to see if you've got any questions at this point. Otherwise, we will go on. Question, is it not feasible that AI could have a look at cold fusion and ball lightning and get on with the reactor design? I suggested using deep learning and I applied for a grant back in 2014, but the UK government wrote back to me and said, well, we've got these grants, but you know, cold fusion isn't really a real thing, so we're not going to give you any money. Right, okay, so I'm going to crack on with this next paper because there's a lot to get through, and although I've painstakingly dug out the important bits, if you want to go and download this paper, I've given the link on the blog at remoteview.icu, and so you can read along with me. Okay. Okay, so I'm going to move that a little bit over here. And I'll put the wrong mouse is on the wrong computer. Okay. Okay, this should be fine. Okay. So this is Slack publication 6473. It's from October 1994. So the work was obviously done before October 1994. It's a model for ball lightning. Well, isn't that a thing? By David Freiberger. And David Freiberger is from the Stanford Linear Accelerator Center, SLAC, from Stanford University. Ooh, Stanford, California, 94309. And it has this little asterisk here, and we go down to the bottom here. And it says work supported by Department of Energy under this contract here. So someone can have a look at this. And he was asked to give a lecture based on his work that he was conducting with this grant from the Department of Energy. He was invited to talk at the first international workshop on the unidentified atmospheric light phenomena in Hessdalen, Norway, in March the 23rd to the 27th, 1994. Well, there you go. Isn't that a thing? Oh, I love how all this ties together. Right, abstract. A model for ball lightning is described. It is based upon the Vorton. Ooh, what's a Vorton? Model for elementary particles. For elementary particles? You're saying there's a thing called a Vorton, which is a model for all elementary particles? Interesting. Which exploits the symmetry between electricity and magnetism. Wow. The symmetry, like the Dirac monopole, magnetic monopole, being the symmetry of the electric charge. That's interesting. The core or driving engine of ball lightning in this model is comprised of a Vorton anti-Vorton plasma. The energy of ball lightning, which derives from nucleon decay catalyzed by this plasma. The energy of ball lightning, which derives from nucleon decay catalyzed by this plasma, leads through various mechanisms to ball lightning luminosity, as well as to other ball lightning features. It is argued that this model could also be suitable explanation for other luminous phenomena, such as unidentified atmospheric light phenomena seen at Hessdalen. Well, there we go. I just love this. I love it. Okay. So I'm going to skip everything I haven't highlighted. You have to read it in your own time to get everything coming together. But anyway, going beyond the collections of ball lightning reports, there are numerous reports of other atmospheric luminous phenomena, which as phenomena intrinsically appear to have much in common with ball lightning, but which are not considered to be related to thunderstorm activity. These other luminous phenomena are often called Earth lights, and it has been suggested that they may be associated with various geophysical phenomena, dynamic ones such as earthquakes or volcanoes, or even static aspects such as fault lines or mineral deposits. However, Earth lights as a category would also include the atmospheric luminous phenomena that have been reported at locations such as Marfa in Texas and Hessdalen in Norway. Okay, so blah, blah, blah. This is talking about the criteria of which ball lightning must be, Okay, I'm going to read from the beginning of this. As an assessment of the utility of a ball lightning model, one can look first at the salient features of ball lightning. As a guide, Uman 12 has proposed as criteria that any valid theory for ball lightning should account for the following features. 1. Constant brightness, size and shape of ball lightning for times up to several seconds. 2. Considerable mobility of ball lightning. 3. That ball lightning doesn't tend to rise. 4. That ball lightning can enter houses and other structures and can exist within these structures. And 5. That ball lightning can exist within closed metal structures. In addition to these criteria, a prime question that any viable model for ball lightning should address is the source of energy that enables ball lightning to exhibit an extended period of luminosity. Catalyzed nucleon decay, the energy source in this model, appears to offer an answer to this question. Wait until you find out how it is proposed that the nucleon, the baryonic matter, is decayed. Wait until you find out how that is proposed. As will be seen later, this explanation for the source of ball lightning energy can also be applied to other luminous phenomena. Yeah, what, like aircraft that use this technology? Right, model. This model is based upon new physics. Well, not that new, it's 1994. Which is not inappropriate, since past efforts to understand ball lightning in terms of known physics have essentially been unsuccessful. Specifically, this ball lightning model is based upon the Vorton model for elementary particles. There's some references there for those that choose to look, which in turn is based on generalized electromagnetism. It was recognized at the turn of the century, that's the century, not this century, the last century, that one could generalize Maxwell's equations to include magnetic charge and current. Magnetic current, we're back to Edlid-Scarlon, as the symmetric partners to electric charge and current. It was later observed in 1925 that this symmetry was continuous, and that the amount of mixing of electricity and magnetism could be described by an angle called the diality angle. In the electromagnetic plane, a basic assumption of the Vorton model is that the diality symmetry between electricity and magnetism is fundamental. This model for ball lightning exploits this symmetry extensively. It was later observed in 1925 that this symmetry was continuous. Magnetism, electromagnetism, EM. Diality symmetry is mathematically founded in a two-potential electromagnetic theory, which recently has been given more secure theoretical foundation by means of diality symmetric Lagrangian formulation. It is a natural consequence of a diality symmetric two-potential theory of electromagnetism that there be a second or magnetic photon to accompany the conventional electric photon. This point has recently been clarified, hence allowing theoretical concepts to lead the way. The existence of magnetic photon and magnetic charge is assumed. A natural extension of this path is that the quantum mechanical vacuum, the Dirac sea, would contain not only usual negative energy particles, i.e. neutrinos, electron neutrinos, protons, neutrinos, I don't know whether it's pions, I don't know, muons, I think that's protons, neutrons, muons, muon neutrinos, etc., but also their magnetic analogues. The reason that these analog magnetic particles have not yet been observed would be that they are very massive. As a first step in the formation of ball lightning, it is hypothesized that the lightning discharge produces a large number of Vorton pairs. Subsequently, a certain fraction of these Vortons collect and form what I shall call the core of the ball lightning. From ball lightning observations, one can make estimates of the electromagnetic charge and energy that would characterize this core. Calculations indicate that there is enough energy available in the lightning discharge to form such a core. However, due to the lack of reliable theoretical calculations and certainly no experimental data, well, now there is, on multi-Vorton physics, there is significant uncertainty about the details of the production of formation processes, and this area is left for future study. Okay. The Vorton. Since the ball lightning model is based on the Vorton, it is useful to first briefly review the structure of the Vorton itself. The charge distribution, which is spherically symmetric. The Vorton carries angular momentum L bar and L bar associated with internal fluxes of this charge density along the direction of this and this unit vectors respectively. Hence, these fluxes depicted in figure 3, which we will show, are orthogonal. These fluxes are orthogonal. So the Vorton carries the blah blah blah. Fluxes of this charge density are orthogonal. The flux around the ring of the radius resembles the motion of a smoke ring and results in poloidal angular momentum. So the flux around the ring of the radius resembles the motion of a smoke ring and results in poloidal angular momentum. Since topological charge is observed, Vortons can only be produced in pairs, and after production are stable, although annihilation is possible. So here's your kind of Vorton with a cross-section. I won't go into detail. There's a better diagram for conceptualizing it lower down, which we'll look at. So this is the distribution here of the charge density. You can see it's highly focused into the central area here. These are your counter-rotating vortex, a slice through it with the material going through, and this is going around the loop. These are conceptual ways to describe it, and this helps with the maths, but we're not going to look at the maths. Is associated with rotation or smoke ring motion. So here's a kind of better one, and you may have seen this used in other people's presentations, which is interesting. It came from here. Okay, so here is the Vorton in the center, and these are the field shapes. We're not going to look at the mass. Okay, so there's a better description later on. So you have something going around here and you have it going around the outside. So this is not too far from a second level tour of Wisniewski. Have I got this? Did I do this? Let me see. Yeah, okay. Diality rotation. Okay, diality rotation plays a key role in the dynamics of this model for ball lightning. It furnishes the mechanism that enables ball lightning coherence, overcoming Coulomb repulsion. So this mode of diality rotation, which is something rotating around something that's rotating, okay? It overcomes Coulomb repulsion, extending ball lightning lifetimes. It acts as a kind of flywheel and the source for ball lightning energy catalyzed nucleon decay. Vorton production. It is proposed that the production of Vortons in Vorton-antivorton pairs that in this model comprise the ball lightning core takes place through the mediation of orphaned magnetic fields associated with lightning discharge currents. So basically, how do you get some orphaned magnetic currents? As the ions and electrons that comprise this discharge current, the lightning discharge, recombine during the course of the lightning discharge, the magnetic fields that they were generating are left abruptly or orphaned in space without source. John Hutchison is doing the replication of the Tesla disruptive discharge. So you have this intense discharge, and what they are saying right here, right there, what they're saying right there is that when you have the disruptive discharge, you get magnetic fields orphaned, okay? Abruptly orphaned in space without a source. Such recombination doesn't take place in metal conductors. So you don't have this recombination leaving orphans in metal conductors. So it's better in free space. Hence, there are no orphan fields in metal conductors, and the Vorton creation process is described below is not expected to happen. This is why you need to create these magnetic charges and then guide them to the metal samples of John Hutchison and then energize them when they're there resonantly. You can't generate these closed magnetic loop fluxes in a metal directly. They need to be built up. Although, you could argue you could create them in the boundaries, so forth, as we've discussed in the past. Okay. Rather than being Hence, there are no orphan fields in metal conductors, and the Vorton creation process described below is not expected to happen. Rather than being radiated away, as one would conventionally happen. It is postulated that some fraction of this magnetic field energy will convert into Vorton-antivorton pairs in situ. The point being that a distribution of suitably oriented Vorton-antivorton pairs, i.e. electric Vortons, will give a magnetic field with the same topology and general shape as that generated and orphaned by the original lightning current. And so there's a lot of explanation which you will have to go into. I've read it all, but I'm just trying to pick out some things to get my point across here. So this is about the range over which a lightning channel can do this. The calculated lightning channel extends out to a radius of 0.5 centimetre, so 5 millimetres. Therefore, considering these results, it appears reasonable to use A equals 1 centimetre for the purpose of calculation. It is also appropriate to observe that A equals 1 centimetre is easily compatible with a mean ball lightning diameter of 19 centimetres in this report, and in fact is not in a serious conflict with the smallest reported sizes of ball lightning, which are on the order of a centimetre, okay, which is 10 millimetres, which is what was produced in the Vega copper from Henk urine. Okay, ball lightning charge and energy content. It is straightforward to estimate a range for the magnitude of the electromagnetic charge in the core of the ball lightning using reports of magnetic effects associated with ball lightning. An estimate for the range of charge in ball lightning core is that 7 times 10 to the minus 7 plus or minus 1 coulombs. I guess that's what it is. blah, blah, blah. So they estimate the charge. Like all your maths are here for those people that are interested in looking through that. Ball lightning core physics. Right. General remarks. In general terms, once formed, the core of ball lightning has a well-defined physical description, which description could also apply to other atmospheric luminous phenomena, much like a plasma, but with important additional features. It is comprised of macroscopically sized vortons and antivotons with significant spatial overlap and with electromagnetic charges in a state of coherent diality rotation with sufficient spatial overlap. Well, let me see what we might have been referring to there. Wait. Oh, where did I put it? No, not there. Significant spatial overlap, I think, would probably include something like this, where this Vorton, if we're going to call it that, has a spatial overlap with this one. That one has a spatial overlap with this one has a spatial overlap with that one. These 100% definitely have a spatial overlap. These definitely have a spatial overlap. There's lots of spatial overlapping going on with these, if we're going to call them Vortons today. Okay. Core mechanisms give the ball lightning a spatial coherence and longevity. Okay, there's an equilibrium point. It is shown in Appendix B, and you can go and read that later, that as a consequence of the diality rotation, this is this rotation round with a rotation around that, okay, in a ball lightning, there will exist attractive forces between like-charged vortons. Interesting. Opposing the usual Coulomb repulsion. These forces are strong enough, in fact, that there is a point of stable equilibrium for the ball lightning configuration. This equation in Appendix B, which shows the trade-off in ball lightning energy between the static E and the dynamic E, is schematically depicted in Figure 9, which is where? Figure 9. Okay, so here's Figure 9, and so you have this. Okay, so you have these two kind of fields, and the Coulomb and the whatever is the diality, and then they cross over, and you have a minima, and that's where you have this stability point. So, for every type of Vorton cluster, or these toroidal clusters, they have a means by which they can come together at a certain distance. Now later it's going to talk about what I talked about a long time ago, is how they can bind on to the back of each other and then form these rings and so forth. Okay. Blah, blah, blah. The equilibrium point A is indicated in the minimum, and so on. Okay. The existence of the stable equilibrium point is important, for it furnishes the ball lightning of this model a mechanism for coherence again, and long lifetime. It is interesting to observe that these results are independent of the number of Vortons in the ball lightning, as well as of the EC, ED, and LD, and omega 0. Then being dependent only on the speed of light, the Compton wavelength of the photon is a fundamental physical constant. So basically, they're saying that this will build and build and build and build and build. Okay? Okay? This existence of the stable equilibrium point is important for furnishes the ball lightning this model mechanism for coherence and long lifetime. It is interesting to observe that these results are independent of the number of Vortons in the ball lightning. Okay. So this here is talking about means by which they blow up and the modes by which they blow up. I'm not interested in that. It's this part of the discussion. Okay, we can now refine the analysis for the equilibrium frequency by taking into account the random motions of individual Vortons and coherent groups of Vortons with respect to the center of momentum of the ball lightning. EK is the form of heat which would derive from the primary ball lightning energy source, catalyzed nucleon decay. In simple conceptual terms, the Vorton kinetic energy generates an internal pressure on the ball lightning that prevents the coulombic charge rising to the duality, whatever. So basically, it stabilizes it. And it should be also mentioned that if the Hessdalen lights are essentially the same phenomena as ball lightning as proposed here, their duration is sometimes of over 1 hour. So they're talking about how long they can last. Like you've got like minutes here, seconds, up to 15 minutes here, and then the ball lightning at Hessdalen, which is one that I spent a lot of time looking at, can be exposed. It can actually run for over an hour. Okay, so here we're getting to the key point. So everyone needs to listen in and listen hard. This is really, really the key point here. Primary energy source. The primary energy source in this model is the energy released by catalyzed nucleon decay. This nucleon decay results from the perturbations to the nucleon wave functions. These perturbations are the direct result of the duality rotation of the electromagnetic charge of the ball lightning. As background information to enable a better visualization of this process, we observe that in the Vorton model, the elementary fermions are comprised of Vorton pairs. The quantum numbers of fermions that distinguish one particle type from another derive from the specific internal structure of the angular momentum helicities of the paired Vorton state, i.e. the fermion. In this model, since baryon number and lepton number are not absolutely conserved quantities, nucleon decay is possible. The conversion of a proton quark to a positron can be affected by perturbation of the orientation of the angular momentum of the constituent Vortons of the pair. You with me? Thought not. Under normal circumstances, however, conversion between baryons and leptons does not take place because the fermions are metastable eigenstates, respecting a symmetry of the fundamental Lagrangian. So this is, you'd think it would do it, but it doesn't. Moving on. The analogy in this ball lightning model would be a proton to positron or a neutron to an antineutrino decay induced by duality perturbations to the original nucleon wave function. When a large number of ball lightning Vortons is present, creating a rotating electromagnetic field, the duality angle of theta 0 of the particles comprising the vacuum, Dirac C, which serves as a reference for material particles, undulates. This is messing with the vacuum. This is disrupting the vacuum. If the driving frequency is high enough, then the nucleons in its presence will not be able to maintain duality alignment with the local vacuum reference. This misalignment will result in a perturbative mixing of the local positive energy, elementary particle eigenstates, which in turn will lead to a finite transition probability between elementary particle eigenstates, where allowed by energy conservation. Okay, so what we're saying here is if the ball lightning is intense enough and it's stimulated at a high enough frequency, then it will change the structure of the physical vacuum such that ordinary matter cannot maintain its stability. In any case, there will be some frequency that defines an empirical threshold above which catalyzed nucleon decay becomes significant. Thus, the criterion for ball lightning energy. Okay, I'm no conspiracy theorist, but it wasn't your internet. I think I'm back. Can people confirm whether I'm back? It's just hilarious that of all the times we should have our first complete cutout, it's literally just after I start explaining the mechanism behind vacuum decay. Okay, all right. That was the most bizarre thing literally at the moment that I'm describing for the first time vacuum decay. I have everything recorded locally here, so you can see what I'm trying to do. Oh my. Oh dear. I know. I toyed with this for years, how far that I was going to take this, but we need a solution, and then this can provide all the solutions that's necessary. Yeah, okay, good. Okay, so we're back in the room. Let me just see if there's any stability problems. I need to switch connections on here as well. So if that's still going to work. Okay. Yeah, that's the first time I have ever had a complete failure of the connection midstream, and we've been in this a while, and it happened when I'm describing the mechanism of vacuum decay. Oh, there you go. All right, is everyone back in the room? Not worried at all. Okay. It wasn't your connection, right? David, you literally just come in at the point of vacuum decay, and for the first time in all of my streaming life, it bombed out at the moment I'm talking about vacuum decay. Right, okay. Okay, so very, very simply, he's describing a Vorton which has things going around this way and also this way, but he's saying that this is, it can go on for basically forever. And the key structure is that the Vortons are the same, or Vortons can aggregate, and that they aggregate in these structures that then at a certain scale and a certain driving frequency, they can do what I'm just about to say here. Okay. When a large number of ball lightning Vortons is present, creating a rotating electromagnetic field, the diality angle theta 0 of the particles comprising the vacuum, the Dirac sea, which serves as a reference for material particles, undulates. If the driving frequency is high enough, then the nucleons in its presence will not be able to maintain the diality alignment with the local vacuum reference. This misalignment will result in a perturbative mixing of local positive energy elementary particle eigenstates, which in turn will lead to a finite transition probability between elementary particle eigenstates, where allowed by energy conservation. There will be some frequency, this frequency to that frequency, that defines an empirical threshold above which catalyzed nucleon decay becomes significant. Thus, the criterion for ball lightning energy generation, and hence ball lightning luminosity, becomes this frequency is greater than that frequency. Where we can tentatively take this, although refinements in the definition of this empirical threshold are to be expected as understanding of this model improves, it is clear, of course, that when WEQ is larger, the nucleon decay probability and hence the ball lightning luminosity will be larger. Okay, so as I've said for a large number of times, if you look at all of the evidence, nothing at all happens, and then everything starts to happen. That means there is a state change in the thing that is causing, the active agent that is causing the process of Leonard to occur, or coherent matter reactions. Therefore, what he's describing is this electromagnetic vortex of vortex structure that gets to a point of such intensity and a certain frequency that it prevents the stability of all kinds of ordinary matter, because they lose their reference frame and stability from the Dirac sea, and so they just fall apart. It's instantly. Okay, this is why I believe when this type of material is going through, say, metal, it leaves a strange radiation track. There is a zero time it takes to do that, because as soon as it's interacting with that ordinary matter, the ordinary matter instantaneously is disrupted and reorganized until it's gone past, and it leaves this trail. It just leaves this trail. And the ball lightning can potentially gain a lot of energy from that. Okay. When WEQ is greater than W bar 0, then the following general reaction is predicted. The Vorton plus the N of the atom goes to a Vorton plus an anti-lepton plus, what is it? Number of pions plus pion. Oh, okay. So these are subatomic particles. So basically, it's the decay, and on either side you've got the V. So where N stands for nucleon, neutron or proton, L bar stands for antilepton, neutral or charged, pi K indicates a pion, kaon, and Nm the number of pions, kaons. QH of the baryon is equal to QH of the antilepton there, thus QH is conserved. The Vorton V is symbolically included on both sides of the equation to signify a kind of catalyst reaction. So basically, when ordinary matter comes into contact with an exotic vacuum object of the right level of intensity and clustering size, it falls apart. It is important to observe that the decaying nucleons that participate in this process and furnish the ball lightning energy are to be found in the nuclei of the atoms in the air or other material, e.g. glass, when the ball lightning penetrates a window at the location of the ball lightning. Details of those nucleon decays which would be expected to occur inside of nuclei and the associated nuclear reactions are explored in Appendix D, which we will look at. Okay. Core heating. We can see that the energy that is made available in the nucleon decay process, represented by equation 20, is almost the full mass equivalent of the decaying nucleon, or approximately 1 giga-electron volt per decay. 1 giga-electron volt per decay. A significant fraction. This is many orders of magnitude higher than occurs in fusion. A significant fraction of the energy is expected to transfer into the degrees of freedom of the ball lightning core, heating the core. In this model, there are two important thermal reservoirs for core heat. One, kinetic energy of Vorton motion, characterized by the temperature Tk, already discussed. And two, deformational strain energy of the individual Vorton charge distribution, characterized by temperature Ts, to be discussed. Since the dividing line between the phenomenology of these reservoirs is the mean Vorton size, A bar, it is to be expected that energy from the latter reservoir would be generating the visible black body radiation discussed below. However, as we shall see, the kinetic Vorton motion plays a crucial role in the observed black body radiation spectrum and intensity. Okay, so within the Vorton, or in the presence of a Vorton, or if we are creating a cluster, a minimalist cluster, which might be like this, then if material is pulled into the inside and it is destabilized by a very altered vacuum inside this structure, then it falls apart and things coming out interact with the Vortons themselves, or the exotic vacuum objects, let's call them. I don't know how these people go through all of this work and not mention chemtrails over and over again. It's like everyone, anyway, it boggles the mind that they don't mention him, and it seems bizarre that this person would be compartmentalized. You know, I just don't believe it, actually. Anyway, so anything coming out will hit this structure. And by the way, this is obviously a minimalist structure. You could have a much larger structure with many substructures. And the toroidal structures themselves are many substructures, as we've discussed ad infinitum. Okay. So this is your electrical charge and this is your magnetic charge. These are local vectors of charge density coming out and interacting. Perturbation in the local charge magnitude will result in electric dipole as indicated. Perturbation in the local diality angle will result in magnetic dipole as indicated. Electric charge magnetically polarized by magnetic fields, or its analog, magnetic charge electrically polarized by electric fields, full diality symmetry is maintained. Okay? So basically, it captures the energy flux. Okay? Because of this diality process. Okay, all right. And then they're talking about that Cherenkov radiation can be a mechanism, or is a proposed mechanism for core heating. And all of the maths is there and everything. It's an extremely long paper, so that's why I'm just skipping bits. Since there is no small-scale structure to the Vorton, it's basically coherent, yeah? Wmax can range up to the full energy of the particle divided by h bar, W minimum, can be set to 0 without introducing serious error. This result shows that the energy lost by Cherenkov radiation will rapidly bring the particle down to the velocity, v gamma, at which point Cherenkov radiation ceases. This is essentially a classical result. This energy enters the core charge as a classical photon-like shock wave. So basically, these things and the substructures are very good at absorbing anything that is thrown at them. Okay? And they're talking about stability here. For positrons, assuming a kinetic energy of 220 MeV, the positron will give up most of its kinetic energy. The Cherenkov process will transfer essentially all of the positron energy, but no muon or pion energy into the ball lightning core. About the highest efficiency one could postulate in which the ball lightning would extract all of the positron, muon and pion energies is 90%. The neutrinos will always escape with their kinetic energy. So 90%, that's immense. That is an immense amount of energy. If we're getting a giga-electron volt from the decay of a nucleon, we're getting 90% of that converted into, photonic energy and electrons. Okay. Black body radiation. The mechanism that is in this model is postulated to be the explanation for the major part of ball lightning luminosity is black body thermal radiation from ball lightning charge. This process appears to be the most efficient in terms of visible photon energy per nucleon. He goes into great detail to explain this. In fact, it is the observation of color changes that is perhaps the strongest argument for a black body radiation mechanism. And talks about color temperature here, different sightings and all these different sightings here and so on. The different observed colors then have a TC which could be directly related to the temperature of black body radiator, where TC will range from 1000 Kelvin and up. However, he then steps away from this. It is possible to account for 90% or more of the observed ball lightning colors with a simple model of black body thermal radiation. The green colored ball lightnings, and perhaps some, remember we saw green in Bogdanovich's work that we were talking about earlier, and perhaps some of the blue ones as well, might be better explained due to Cherenkov radiation. This is basically leaking out from the core. These are the weird glows. Okay, so in this document, and maybe he's not talking about it here, but he talks about that maybe later on he talks about it, that actually it's not actually that hot. There's a disconnect, and that it could be due to a Doppler effect, and then maybe it's talked about later. But if you go back and look at the Valery Zatelepin presentation, he showed that the spinning of real and artificial ball lightning is incredibly fast, and it creates a red-green Doppler shift because it's that fast. It's relativistic type speed. Okay, and he talks something similar about it here. Optical thickness. When the radiator is too cold to radiate a significant amount of energy in the optical region, it will completely absorb the optical radiation that falls on it, manifesting a totally black object. So that's a black EVO. Keeping these features in mind, it is possible to argue that we are, more likely to be, dealing with a black body radiator, an optically thick source. Totally absorbing objects are particularly strong evidence for the black body versus grey body model. Okay? And we have observed that these structures form toroidal structures that have a very defined thick boundary, which would be optically thick, effectively, wouldn't let light pass through it. Furthermore, black disks or balls have been seen in conjunction with volcanoes, right? So, as an example of the hot radiator case, a scientist known to the author got an excellent opportunity to observe blue-white ball lightning from close range, 50 centimeters, to concluded from the distribution of the intensity over the sphere that it was an optically thick object. As examples of ball lightning in the secondary category have also been observed. Furthermore, black disks or balls have been seen in the conjunction with volcanoes. I think the disks are probably the toroids. Okay. Right. Okay, so this is where he's talking about paradox, because what it is there's this case where ball lightning, I've spoken about it before, where the ball lightning went into a barrel and it boiled off all this water, and how could that be, or so on. Anyway, but other people find that when they are witnessing ball lightning, it doesn't feel like it's hot. It's not like 1,000 Kelvin or whatever. Thus, we have arrived at a paradox. The character of the bulk observations suggests that ball lightning and other Earth lights are black body radiators at some appropriate temperature, but a straightforward calculation of the total radiated power by such a black body using the appropriate colour temperature yields total intensities far too large to be in agreement with observed intensities of light or heat. One way around this problem would be to assert that ball lightning and also Earth lights are optically thin, but as discussed in this last section, this is not in accord with the cases of total black body absorption. The resolution is, at the same time, these BL Vortons, when viewed as a gas, are moving the velocities consistent with their kinetic temperature, TK. These motions will Doppler shift the radiated black body energy to a higher colour temperature when they are towards the observer, and shift it to a lower colour temperature when they are away. For ground state ball lightning Vortons, A equals 1 centimetre, these velocities will be relativistic. Right, so if you've got something spinning around, and it's so fast, when it's moving towards you, or that it's spinning that towards you, it's going to downshift it all the way maybe to black. and it's going to upshift it all the way up to something quite light, is basically the argument. And certainly the evidence shared by Valery Zetalepin in 2018 would support that of real and artificial ball lightning observations. Thus, this mechanism renders it possible to have a TC appropriate for blackbody radiation into the visible spectrum and still have relatively cool, low-power radiator. The problem is resolved. So that fixes the observation to the temperature thing. Thus, the estimated core temperature is 100 degrees centigrade. Remember we said that water came out of a ball lightning? They're estimating that the core temperature is 100 degrees centigrade, so that wouldn't boil the water. Somewhat above ambient, but not that much, and is consistent with observation, i.e. no noticeable heat. Using a Doppler shift factor of this would yield that. Okay, so they explain it. Black body radiation. In Appendix D, using data for pions stopping in carbon, estimates are made for the more likely secondary reactions that can be anticipated as a result of the primary nucleon decays. So if a pion is interacting with matter, it's going to cause some secondary reactions. Okay, there's some scintillation light, but he says that this is even lower. Would generate considerable local ionization, which would lead to a component of ball lightning luminosity by scintillation of local air molecules. So we talked about something similar before. This is small, however, 3% in comparison to the yield by black body process estimated above. So they're saying that only 3% of the light would be coming from a scintillation process. Okay, corona discharge is even lower, and some general remarks. Talks about the ball lightning shape, elliptical, pear-shaped, disc and cylindrical. Elliptical, which we've observed on the Vega Valley. Pear-shaped, maybe. Disc we've definitely observed, which I think is a toroid, and cylindrical. Okay. Now here he talks about ball lightning motion. I think some relevant points here are: it is proposed that this negative residual charge that at the ball lightning and the ionic currents that it induces in the air are major factors in the motion of mobility of ball lightning. Away from the ball lightning region, builds up a surface charge on the ground that would be of sufficient strength to cancel out the original field from the cloud. At this point, there will be a vertical equilibrium, but the ball lightning would still be free to move horizontally. So this explains why ball lightning is able to float above the ground. If the ball lightning can basically, the ball lightning is emitting electrons the whole time, and so this can statically charge things around it, and so it leads to stability in terms of its movement. If the ball lightning inside a room, as is often the case, then these radially moving negative ions will deposit on the walls. One assumes that the high energy particles from the nucleon decay will penetrate the walls and thus be too far away to influence ball lightning motion. And if the walls are poor conductors, these negative ions will build up a static surface charge. This accumulation of negative charge on the walls will tend to repel the residual negative charge at the location of the ball lightning. This effect would lead to the observed motion of ball lightning parallel to the walls of the room, i.e. so it comes close to the wall and then it builds up some charge and that keeps it away from the surface. And this is what Ken Shoulders used. He actually used dielectrics. He would make a channel and then he would fire the ball lightning down this dielectric channel, and it basically stays contained without touching the walls because it charges the dielectric, and so it stays in that channel. It can move down. You can see all this in his patents and other writings. Okay. So he's using something that what ball lightning is observed to do in manipulation of exotic vacuum objects. This effect would lead to the observed motion of ball lightning parallel to the walls of the room. In addition, one can see that this effect would also account for the fact that ball lightning often tends to avoid walls and various other solid objects, often opting to go through any open window or door. This mechanism could also account for the often seen propensity for ball lightning to move toward a conductor. If the conductor has a path which tends to drain off the negative charge to ground, then it, like the open window, will represent a place where there is no negative charge build-up. The negative charges on the surface will push the ball lightning towards the conductor. Okay? So, essentially, he's explained why it doesn't like to go towards dielectrics, and why it likes to go to or insulators, and why it likes to move towards a metal conductor. Okay. And then he talks about rapid motion here, up to 18,000, I guess that's miles per hour, 8,500 meters per second. And he talks about splitting or connecting. Not only does the mechanism of diality rotation give stability to the individual lights, it can also give stability to geometric configurations of two or more lights. So you see this at Hessdalen. Right. Coulomb repulsion and the kinetic plasma pressure take over, and the Vorton plasma disintegrates, dispersing the Vortons. Okay, so if you have a ball lightning blowing up, we know from our work in the 10-yen coin exposed to the Mars gas, micro ball lightning was formed. This would be structures of the larger structure, and they did the snowballs on cobblestones, the converting of the copper oxide, the oxygen in there, to sulfur. And you can see the explosion of a large ball lightning in Uretskyev's work to smaller ball lightnings, and also some things similar in the work of Matsumoto. Okay, so this is a review. So for those people that have gone to sleep, this is the time you should probably be listening. Recapitulation. At this point, it is useful to summarize the observed discussions by reviewing the salient features of ball lightning as described by this model. The core and driving engine of ball lightning is a coherent plasma of a large number of Vortons. Boom! This is exactly what we have derived from observations prior to reading this. There's no physical observations in this. None other than reporting what ball lightning does in the past. There's no physical observations of experiments, but we derived that there from observing physical damage in experiments. Okay. The coherent diality rotation of these Vortons, acting much like a mechanical flywheel, not only furnishes coherence forces for the ball lightning, but also catalyzes local nucleon decay. High energy particles, mainly positrons, from this nucleon decay transfer by Cherenkov radiation a large fraction of their energy into the degrees of freedom of the ball lightning core, heating the core to a modest temperature of around about 100 degrees centigrade, okay, 320 to 400 degrees Kelvin, say. So here we have something that is not hot, okay. So hold on a minute, hold on a cotton picking minute. What is 400 Kelvin? What? Oh. This is real time. I've just realized this. For those that are watching, I've just realized this. I cannot believe this. Oh my God. Oh my God. Ha! To 400 Kelvin. Do you know what 400 Kelvin is? It's 126.85 degrees centigrade. You know what that is? It's almost exactly the temperature of HHO gas that we determined in the bolometer tests and that other people have determined from other temperatures. So this gas is basically what they would call a whole bunch of Vortons. And they aggregate on your metal and they get a little bit hotter, but not hotter. And the structure is a ball lightning. It's a self-organizing structure. It's what we saw on the 10 yen coin. What we saw producing these toroidal structure on the tungsten, which well below the melting point of tungsten and well below the boiling point of tungsten at lower temperatures, it is causing the nucleon decay, which we observed on the sample. We observed in a filter that captured particles coming off. Transmutation. How cool is that? How cool is that? Amazing. The heated core, acting like a black body radiator, radiates this energy in Planck black body distribution. The relativistic motion of an individual, Planck black body distribution. There you got it again. There you've got it again. Why, when the thing is not hot, do you have the ball lightning that's on your sample being exposed to by a maser gas? Why is it so bright? Why is it so bright? Because the surface is emitting intense black body radiation, but it's not that hot. It's not thermally hot. It's intense black body radiation. Wow. I love these two sentences. The relativistic motion of the individual Vortons, also a manifestation of core heat. So, as the heat grows, this can cause, this basically goes into the coherent Vorton condensate, the coherent exotic vacuum object cluster, the ball lightning cluster, and then the cluster prevents the particles and gamma radiation and photons or whatever's coming out from getting out, and it converts it into the motion of the individual Vortons. Also a manifestation of core heat, causes a Doppler shifting of the frequency of some of this black body radiation pickup to Planck distributions with visible color temperatures, red, orange, yellow, white, and perhaps blue, in accord with most of the observations. It is this Doppler upshifting which enables consistency between the observed color temperature of ball lightning and of several thousand Kelvin, and observed heat and light output of ball lightning very limited. So you could look at this with a color temperature and think that it's very, very hot, but actually it's not. That is just the photons being Doppler upshifted, okay? the actual temperature is much lower, and it is this temperature, which is about the temperature of HHO, a Mars gas. So here you have many things that explain some of the things we have observed. The sometimes reported black ball lightning and Earth lights would be a coherent core, but one too cool to radiate in the visible range, even with Doppler upshifting. As a black body, it would absorb all visible radiation and manifest itself as a totally black object. What, you mean like these totally black objects here, absorbing all light in the work of Bogdanovich? Interesting. The extensive range in size, luminosity and lifetime of the ball lightning and Earth lights phenomena then can easily be accommodated by the mechanisms of this ball lightning model. Earth lights would be governed by the same physical principles but would be comprised of more Vortons. So Earth lights are things like occur in Hestalin, but also these things that occur at a much higher atmosphere that you see when you're looking down from the space station or some of these rockets and go, oh, there's a load of UFOs. And no, it's ball lightning moving around, or Earth lights, okay? So yeah, there's a lot of these phenomena that are just, I'm afraid they're just variations of this, okay? It is suggested that various ball lightning and Earth light shapes, in addition to the most common spherical shape, would be made possible by ferromagnetic-like interaction of the dipole forces of the individual Vortons. Ferromagnetic-like interaction of the dipole forces of the individual Vortons. Interesting. Okay, so there's a lot of detail here. Right, for assessment. Constant size, brightness and shape of the ball lightning for periods of up to several seconds. A mechanism, diality rotation of the intrinsic electromagnetic charge that holds the ball together, is an integral part of this ball lightning model. The energy and momentum stored in this diality flywheel is central to this mechanism, giving the ball lightning its longevity. In addition, it would operate to maintain the size of the ball over its luminous lifetime. At the same time, this mechanism catalyzes the release of the energy that results in the luminosity of the ball lightning. Since dissipation of diality angular momentum can be expected to be a slow process, diality rotation does not furnish the ball lightning luminosity directly, but rather through a catalysis process, the energy release rate can be expected to be relatively constant while the omega exceeds this critical threshold. When omega reaches the critical threshold, the nuclear decay reactions and hence the luminosity effectively cease. Given a sufficiently large initial impulse of diality torque, this model easily extends to comprehend the durations of long-lived ball lightning and even can include the lifetimes of 1 hour or more exhibited by the luminous phenomena observed here at Hestalin. So, if you can produce a ball lightning that has this structure and you can keep kicking it every once in a while, it will support itself. You just have to exceed this critical threshold. So all you need to do is occasionally go boop, prod it. Just here's your ball lightning. We get it up to its critical threshold where it starts to consume matter and convert it into light and leptons. And then all you need to go is, as it drops down through that critical threshold, you go boop, I'm not mad, let me out. Okay. All right. So you might only need to give it a little bit of extra energy to keep it bumping along. Okay. Given the sufficiently large initial impulse of diality torque, this model easily extends to comprehend the durations of long-lived ball lightning and those of Stalin. The considerable mobility of ball lightning. Once formed, the ball lightning of this model does not depend upon any external power source. Hence, it has no need to attach itself to anything for sustenance, as does St. Elmo's fire. The ball lightning motion will be dictated by the electrostatic forces deriving from the charge imbalance and radial currents resulting from proton decay. Since the ball lightning is a coherent but detached entity, it does not need to follow the motion of the local air. Ooh, interesting. Wind. One anticipates that electrostatic forces could easily dominate aeolian forces. Ball lightnings that do not move along with the local wind are frequently reported. The observations of ball lightning outside of a flying aircraft but moving along with it are even more relevant. So here we have something that is able to move exactly as Tesla described in his Times article, I think in 1911, that would permit moving at any speed regardless of the weather conditions. Why? Because it just doesn't care about the air. It hits that structure and it's immediately converted into things to keep it going. We've explained the ball lightning doesn't tend to rise, it has stability. We've explained the moving around in structures. The ball lightning can exist within closed metal structures. The criterion militates against ball lightning models that draw their energy from some external electric or electromagnetic source. So basically, by knowing that ball lightning can exist within closed metal structures, and there's an example of this that came after this work, which we're going to discuss in the next paper, which is much shorter, you'll be glad to know. This criterion militates against ball lightning models that draw their energy from some external electric or electromagnetic source. So like the Kapitsa model that needs microwaves, yeah? The Jennison report, in which ball lightning was observed inside a modern aircraft, is typical as a basis for this criterion. Since the source of energy for the ball lightning in this model is local, nuclear, this criterion poses no difficulty. So here's some predictions. There would be also contributions from positive pies, muon, and positrons and positive muons. I think there's so on, decay chain, blah blah blah. Is this what's okay. So this is predictions. You can go and read it. It's very, very detailed. However, even though this voltage might be as high as 10 to the 6 volts or more, such a voltage would be difficult to reliably detect during a thunderstorm conditions. Although it is certainly large enough to administer a serious electrical shock. So people have been known to interact with ball lightning and get a serious electrical shock, as is postulated here by the amount of charge that can build up on it as a result of baryon decay. Okay, proton decay. Right, so sixth. As with any electrical gas discharge, one might realistically expect avalanching and other unstable variation in ionization due to the current to lead to electromagnetic interference detectable on radios and TVs, just as John Hutchison observed, but it's also in that 1920 something or 19 it's much earlier than John Hutchison, where people were observing these crackling. It is also possible that vibrational modes of the ball lightning charge as a whole might be excited, like the giant dipole resonance in nuclei, leading to strong radio frequency emissions of quasi-line spectra. A seventh prediction is that due to the diality rotation, there should be low frequency oscillating electric and magnetic fields associated with ball lightning. A seventh prediction is that due to the diality rotation, this is like something rotating with charge going round something else, and that this goes EM without doing it to the level that was discussed by Zverblis and Nevesky. The frequency of this oscillation would be expected to be a few hertz. The frequency of this oscillation would be expected to be a few hertz. While it would be almost impossible to convincingly observe such an oscillating electric field in a thunderstorm, it is conceivable that one could detect a rather small oscillating magnetic field. Blah, 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 blah. Right. It is of interest to examine, in the context of this model, the water tub account. As reported in this account, the ball lightning entered the tub of water, I've spoken about this before, causing the water to boil. The heat released in this incident has been estimated to be 3 times 10 to the 6 joules. Now, in this ball lightning model, one expects that the nucleon decay rate triggered by the ball lightning will be proportional to the density of nucleons at the location of the ball lightning. Hence, Since water is 800 times as dense as air, it is straightforward to estimate that when immersed in water, our nominal 1008 Curie's ball lightning will release energy at a rate of, whatever that is, 8 megawatts. Due to higher energy density of water, a good fraction of the released energy will be deposited locally in the water, heating it. For the sake of argument, let us take the heating efficiency to be twice that for ball lightning in air, or 20%. Thus, the 8 megawatts of total available ball lightning power yields a heating power of 1.6 megawatts. At this rate, it would take about 2 seconds for a typical ball lightning to deposit the estimated 3 times 10 to the 6 joules in the water tub. A smaller ball lightning would take somewhat longer. Thus, the contradiction is resolved if an intimate contact with a dense material, ball lightning can generate very large amounts of heat, and yet in air it can appear to be intrinsically a relatively cool object. As to electromagnetic effects, it is appropriate to mention again the event of Dmitriev. He noticed an ongoing static on a small radio. This is this much earlier example, I think. Yes, it is. I've talked about it before. He noticed an ongoing static on a small radio while the ball lightning was in the vicinity. Similarly, during some of the Hestalin events, a certain amount of television interference was observed. The motion of the compass after the event is interpreted in this model as being due to the coherent but non-luminous stage of ball lightning, for which WEQ is less than the critical value. In the context of this model, both of these cases, and in particular the latter, indicate that W0 is a fairly low frequency. If W0 were more than a few hertz, the inertia of the compasses would preclude such a response. Okay? So it's not a large amount of rotation in the diality when it's in the non-luminous stage. Present-day experimental limits indicate that W0 is greater, approximately 1 second to the minus 1. Blah, blah, blah. Okay. One possibility to explain the oscillations in the context of this model would be to assume that the luminous object entered a region of high electrostatic field, with which the varying electromagnetic charge due to diality rotation and at the frequency WEQ of the ball lightning was interacting. Okay, so with reference to the above estimate of W0, it is relevant to note the account of Dmitriev et al., in which ball lightning was observed to pulsate in size and luminosity with an estimated frequency of 3 to 5 hertz. In this model, this would be a consequence of W is greater than W bar 0, associated with luminous stage. In this regard, it is important to point out that there is a photograph of a luminous object taken in 1984 in Hestalin, in which the track of the luminous object was observed to oscillate with a frequency of 7 plus or minus 2 hertz. Now, everyone's going to say Schumann frequency here. Consistent with the ball lightning model of this paper, Figure 13 reproduces this photograph. So Figure 13 is here. We've shown this image in our Hestalin ball lightning video, and you can see these oscillations. You have the track length is total exposure time, it's 10 seconds, and you can see the number of oscillations here. And so what he's arguing is that you have the luminous object entered a region of high electrostatic field with which the varying electromagnetic charge due to diality rotation at the frequency W. So basically, the strange radiation, the spiral tracks we're observing maybe in the Vega experiments, so listen up, David, and listen up, Henk, if you're still with us, could be that you have this diality rotation on these structures, and as it moves through, it interacts with the electrostatic field in there between the two electrodes, and this causes the observed spiraling motion. Okay. Or sets it in motion. Conclusions, acknowledgements. Okay, so it's actually a couple of things from the references that are important. This assumption is justified below, where it is shown that due to diality rotation, there are coherence forces which tend to synchronize the diality angles of the constituent vortons. So basically, because these things come together and push together, you can imagine that they're a load of metronomes on a plate, and they are then forced into synchronization. Okay, so then they all become completely coherent, and the maths is there for you to explore if you wish to. We now see the origin of internal coherence forces in this model for ball lightning and Earth lights. Looking again at the mechanical analogue for guidance, we consider briefly the rotating figure skater. Here we see that there is a centrifugal force given by minus d blah blah blah, where blah is the kinetic energy of rotation. This centrifugal force tends to extend the skater's arms, increasing the moment of inertia. The effect is to reduce the kinetic energy of rotation, putting that energy into whatever object is resisting the centrifugal force, e.g. the skater's arms. Since the skater exerts no torque on any external object, angular momentum is conserved in this process. In this model for ball lightning, the analogous force is given by this, where that is an appropriate coordinate parameter for the individual vorton, of which there are two interesting sets. One is the distance this of that vorton from the center of charge of all of the rest of the vortons, and the other is the diality angle theta I of that vorton with respect to the mean rotating diality angle of the rest of the vortons. As with the skater, both of these forces will tend to increase the amount of inertia of the system, reducing the energy of diality rotation, while conserving angular momentum. One sees that then that the force this will manifest itself as a force of attraction between the vortons of like charge, like charge, whether it's magnetic or electric, in opposition to the repulsive Coulomb force. So this is a Coulomb in charge, I guess, electrical charge, tending to increase EC and giving a spatial coherence to the ball lightning. Similarly, the force this will also tend to increase ID and hence EC. It does this by synchronizing the rotation of the vorton's diality angles. The forces of that are, of course, opposed by the forces of that. These two sets of forces are at an equality at the equilibrium point found above, at which blah blah blah. In essence, the action of these forces transfers energy between ED and EC to minimize total energy. The result is an equilibrium point at which there exists attractive forces are strong enough to hold the ball lightning core together in a state of equilibrium, once the core has been formed. This is the mass for that. Right, ball lightning radioactivity. Simply put, the model for ball lightning radioactivity is catalyzed nucleon decay, described by equation 20, where the nucleon is a member of the nucleus of an atom at the location of the ball lightning. One of the quarks in the nucleon makes the transition, but there are two other spectator quarks that still are hadronic in nature. These will lead to non-baryonic hadronic debris, i.e. pions and perhaps some kaons. In the same spirit, the following possible reactions represented by equation 20, assuming n equals 2, I got another mosquito in here which is going to be biting me, n equals 2 and m equals 0 are recorded. So you've got a vorton on either side, you've got a proton and it goes to a positron, a positive pion, a negative pion, I think that is. A vorton with a proton goes to a vorton plus a positron, a pi 0, 2 pi zeros. Vorton and a proton goes to a vorton and a electron antineutrino, a positive pion and a pi 0, and so forth. So you get all these different reactions that are possible. Final states with electrons and electron neutrinos are precluded by conservation of QH. Reactions to positive muons or whatever, what you would call those, not positron, anyway, someone can tell me, and muon antineutrinos in the final state are also possible, but their inclusion above would not substantially change the energetics, although the muons in the final state would be much less efficient at heating the ball lightning core. For simplicity, it is assumed each reaction of equation 20 has the same probability. Further, it is assumed that the leptons escape the nucleus with no energy loss, i.e. they are the full energy, and that one half of the pions also escaped without energy loss, the other half being absorbed. Actually, since the nucleons are decaying inside the nucleus, the pion absorption rate probably exceeds 0.5. But again, at this stage, such a refinement is unwarranted. Since air is 80% nitrogen, we can assume without serious error that the nucleon decays inside a 14 nitrogen nucleus when a proton decays to positron and electron antineutrino. We get 14 nitrogen goes to 13 carbon plus a positron or electron antineutrino and 2 pions. Okay? So, and the pions balance the charge. Similarly, when a neutron decays to a positron or one of these, positron and electron antineutrino, we get, this goes to 13 nitrogen. Okay. So right here, you're seeing, I've got it. It's dead. We are seeing here how I said in the event that the air, the 78% of air, which is 14 nitrogen, was the fuel. And here we go. We have potentially 1 gigaelectron volt per neutron per nitrogen nuclei that it has one of its nucleons, one proton, decayed, and this will excite the process to continue. And of course, this will create a very large exotic vacuum object, which could affect magnetometers, even when they're thousands of kilometers away. Anyway, that being said, let's move on. Thus, we have 440 megaelectron volts escaping kinetic energy at 220 megaelectron volts, plus 140 megaelectron volts equals 360 megaelectron volts being absorbed into the nucleus. 360 megaelectron volts is more than you get from the fissioning of uranium-235 or plutonium-239. Okay. The absorbed pion will heat the nucleus, causing a variety of particles to evaporate. So I think this is firing something into carbon, and so they actually know the data on this. So you get these energies here, blah, 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 blah. These are the energies you get. This is decay process, and so on. It's a very, very well detailed paper. Exactly what you get out of it. La la la, and the energy levels of it. Right. This is very, very important. Appendix E, ball lightning decay driven current. Due to catalyzed nucleon decay, the ball lightning has the character of a current source. Okay, let me say that again. Due to catalyzed nucleon decay, the ball lightning has the character of a current source suspended in space. This current, which is due to the excess of long-range positive charges leaving the ball lightning region, will be radial in flow pattern. What you've just read there is that if we get exotic vacuum objects and we can cluster them into a structure that will self-sustain for a period of time, that you just need to go boop, boop, boop periodically to kick it, it will then consume matter. It will take baryonic matter like protons, and it will produce light and leptons. Partly the leptons are directly produced, partly it's from decay of subatomic particles. Those will interact along with their energies with the ball lightning structure, with this diality structure, and that will convert into more light through heating the core, and that converts mostly to black body radiation and some ionization. Okay, so you get light and leptons. And if it's in free space and you feed it just enough gas to keep it going, it will throw out light and leptons. The positive particles will go into the far field, and so you will have a zone around which you can harvest electrical energy. And then you have to feed that to ground. You have to have somewhere to dump it, right? It has to be grounded. So you can use that electricity to go through something. And maybe it could be charging something. It could be, just doing something, right? This, I think, is probably one of the most important sentences in this whole thing. Due to catalyzed nucleon decay, the ball lightning has the character of a current source. Point in space that just gives you electrons. Suspended in space. This current, which is due to excess of long-range positive charges leaving the ball lightning region, will be radial inflow pattern. From measured ozone nitrogen dioxide ratios, a voltage of -4 times 10 to the 5 volts equals -3 times 10 to the 3 stat volts, whatever that is, for a ball lightning of radius, maybe that's over the whole surface, 10 centimeters, implies a net ion charge of 1.3 times 10 to the 4 EZU. If the driving current is large enough, this voltage may be sufficient to create additional local ionization. That is, it could generate a corona discharge. But they say that it's too small compared to the black body discharge. Now, interestingly here, they're talking about estimate of residual radioactivity. One can use the estimate of ball lightning radioactivity in the air to estimate the residual radioactivity in solid models that come into contact with ball lightning. I make such an estimate here for glass, since it is often penetrated by ball lightning, frequently with witness present. While the composition of various types of glass vary considerably, the major component of most commercial glasses is silicon dioxide. As a result of catalyzed nucleon decay, one expects the silicon and oxygen nuclei to yield daughter products of lower Z. Upon consulting the radioactive nuclides listed, if we take 28 silicon, we find that we can get these kind of nucleons. Now, in the event, there was a 50 times background radiation of tritium produced, and he's saying that we predict that some tritium can be produced. And we do see tritium produced by Lena processes. But down here we have sodium-28. Now what's really, really interesting is we saw a lot of sodium all over the Vega Valley. He's saying here that in addition, sodium-22 has a characteristic signature that would be easy to detect. The two 511 keV gammas from the positron electron annihilation and the 1275 keV gamma per 22 Na decay. And this is 2.6 years. When I read this at 2 a.m. or 3 a.m. this morning, just under 22 hours ago, what I did is I took the gamma detector, the radio code, off the Kerala sand where it had been sitting for 66 days getting a lovely spectrum, and I moved it over to Henk Uren. He has this quartz tube which protected the anode, and on there had been what are very clearly, and I will document these in beautiful detail when I photograph them and do my microscopy on it. These exotic vacuum object strikes, where you see this toroid there, and even with some radial patterns. I think these probably will be far in excess of the quality of the ones that were observed by Bostic and Nardi published in 1980. Anyway, that being said, if he is correct and that this is producing sodium-22 and it has a half-life of 2.6 years, well, that sample was produced maybe a year and maybe 7 or 8 months ago. So there should potentially be some activity left. It might take a good number of days to get any signal, but I've got it in there as from about 22 hours ago. I haven't looked at it yet. But if we see these 511 keV gammas, and we see this 1275 keV gamma, then we can confirm this theory to a degree. So this is pretty exciting. We have this experiment ongoing as I'm talking to you right now to potentially convert this theory. Confirm this theory. So the reaction of interest then is 28 silicon plus a Vorton goes to, or I would call this a ball lightning, goes to 22 sodium plus a Vorton plus whatever's left. Where X stands for all other reaction products, like whatever you get out there. Fragments of 28 silicon. Yeah. And so that is that paper. So I got this paper because someone pointed me to a paper that was published not in October 1994 and funded by the US Department of Energy, okay, and presented some of this material in March the 23rd, 1994. I got this because I was pointed to this paper, which we will go over in a little while, which actually is expanding the theory a little bit more and getting it closer to what Zverblis and Nevesky were saying. Of course, that is a physical analog, I believe, of vacuum engineering technology that the exotic vacuum objects do for their daily bread and butter. Okay. So, just in review of that 1994 paper, we have shown how the structures that we are producing in a range of experiments like Ultra and like Vega and like Nova, Supernova and so forth, that these are produced in the Hutchison effect and in all the other ones that we regularly mention. These are producing solitons, and the solitons have this, what they call a diality moment. And essentially what happens is when they get energized to a certain level and clustered at a certain size, they then distort the Dirac sea to such a level that ordinary nucleons cannot keep their reference frame with the local Dirac sea, and they fall apart. And that's it. That is vacuum engineering, that is vacuum decay, that is what is going to provide us with the next step change in our species development. That is this. That is what we are doing. That is what you saw, in my view, occurring on Henk Uren's sample, that ball lightning cut copper. The material has disappeared. It's disappeared. It's not melted. It's not melting. It's not melting because we're talking about something that has a surface temperature, nominally, of about the temperature that the HHO gas records as, nominally, right? I mean, maybe we could consider HHO gas as the whole bunch of Vortons, just itty bitty ones. And when you put that on a metal structure, it's then forcing them to cohere and cluster. And then it does its magic, which is entirely consistent with everything we've observed across many, many different systems. Entirely consistent. And you get a brighter look, although it's thermally a lower temperature, because you're exciting the Vortons into clusters that then increase the diality rotation to a level where it's relativistic, and it produces a thing that gives you a much brighter light. But it isn't that light. That's not what's happening. It isn't that temperature. It's just giving you photons at that temperature, making you think it's hotter. So if you use the wrong technique, which it would appear that potentially the Japanese university did when they assessed the former temperature before, and assumed that matched the melting point of tungsten, but that isn't what happened. They are seeing something, but that isn't the real temperature of what's going on. It's accelerated light, I guess. So, it's a Doppler effect. Yeah. Okay, so I'm going to do this second paper. It's not so long, you'll be pleased to know. And again, there's a lot of repetition in there, but I've just highlighted. In fact, have I highlighted? Oh no, maybe I didn't highlight. Oh yeah, I've really only highlighted a few things. Okay. Oh, hold on, I've got some unobtainium down in the drawer here. It's perfectly possible to get. Oh no, maybe I didn't put it in that drawer. Okay, so let's go to this. A ball lightning model as a possible explanation of recently reported cavity lights. Now, recently reported? Nah, I don't think so. This is April 2009. Yeah, so the previous paper was 1994. This is April 2009. And this here is funded by who? Oh, it's supported by the Department of Energy. It's still supported by the Department of Energy. This guy is still going on about ball lightning at the Stanford Linear Accelerator, whatever, National Accelerator Laboratory. He's still doing it at Menlo Park, by the way. Menlo Park, right, exactly next door to where ICCF 24 is going to be held. Okay, right next door, and it's supported by the Department of Energy. It's bonkers. It's literally bonkers. Okay. So, the salient features of cavity lights, in particular mobile luminous objects, MLOs, as have been experimentally observed in superconducting accelerator cavities, are summarized. A model based upon standard electromagnetic interactions between a small particle and the 1.5 gigahertz cavity excitation field is described. This model can explain some of the features of these data, in particular the existence of particle orbits without wall contact. While this result is an important success for the model, it is detailed why this model as it stands is incomplete. It is argued that no avenues for a suitable extension of this model through established physics appear evident, which motivates an investigation of a model based upon more exotic object, ball lightning. Basically, they're saying, you can't explain this with any standard physics, so we're going to have to go to ball lightning. As discussed, further motivation derives from the fact that there are significant similarities in many of the qualitative features of ball lightning and mobile luminous objects, even though they appear in quite different circumstances and differ in scale by orders of magnitude. Scale invariant, my friends, scale invariant. The ball lightning model, which incorporates electromagnetic charges and currents, is based on a symmetrized set of Maxwell equations, in which the electromagnetic sources and fields are characterized by a process called diality rotation. It is shown that a consistent mathematical description of diality rotation as a physical process can be achieved by adding suitable phenomenological current terms to supplemental to. Now this is absolutely totally critical when you go back to Zverblis and Nevesky. Can be achieved by adding suitable phenomenological current terms to supplement the usual current terms in the symmetrized Maxwell's equations. These currents, which enable conservation of electric and magnetic charge, are called vacuum currents. Vacuum currents. Vacuum currents. Are we there yet? So what he's talking about is this paper. Light emission phenomena in superconducting Neue boom cavities. Single cell test results. During the testing of a cavity, 3 classes of glowing filaments were observed: regular shaped closed, irregular shaped closed, and open. These filaments were located mostly in the center of the beam axis between the irises. The closed and open filaments were repeatedly observed. And there's another mosquito that's met his doom. The closed and open filaments were repeatedly observed during the 1 to 2 hours of testing, and some of the patterns lasted for several seconds. The closed filaments changed plane of rotation frequently during the few seconds and varied in size from 3 centimeters in diameter to larger than 7 centimeters in diameter. The diameter of the cavity beam tube. During both closed and open observations, filaments generated reflections on the beam tube and irises. From the videotape, consecutive frames were analysed to determine the frequency of oscillation and the velocity for the closed and open patterns of light. The closed filament's frequency of oscillation was about few tens of hertz. Few tens of hertz. Interesting. The open filaments had a velocity of a few meters per second. Okay, so here is a luminous object in our superconducting cavity. This is our cavity arrangement. You can go and have a look. These are more luminous objects. A luminous object here. These are long luminous stringy objects that move around the surface. And here are a range of luminous objects moving around. Blink, 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 blink. Yeah. Interesting, eh? At approximately 4.4, I think that's megavolts per meter, several closed filament occur at the center or cell of the cavity at the same time and lasted for several seconds. The glowing point sources at the irises and the multiple closed filaments are present in figure 5. As with a single cell cavity test, the 5-cell generated closed filaments following a flash of light. So this occurred because of a flash. They occurred after a flash of light. What is that? Well, I think Georgi Messias might have an explanation for that. It's called an ecton, which is a Coulombic explosion, and ectons are and will become exotic vacuum objects. Okay, all right. It's all the same thing. All right. So, oh dear, did I actually highlight any of this? I've talked about it elsewhere, but where are we? Nothing on that page. Let me go to the full page. Like I say, there's a lot of repetition in this, although it does improve the model somewhat, but there's just a couple of things I want to take out of this. It should be mentioned here that special geometries, i.e. very thin spherical shell... Oh, well, hold on, hello, what is it saying? It should be mentioned here that special geometries, i.e. a very thin spherical shell or long needle, aspect ratio of 300, were shown to be able to circumvent the density criterion posed above for solids. These geometries offer a much larger induced electric moment per unit mass. Ooh, a very thin spherical shell. Well, where have we heard that before? I think we might have seen that physically. Well, it's nice to have a hypothesis. Okay. It notes here that a Bose-Einstein condensate is too fragile and too light to be viable. So let's forget that. It is a condensate, but not in that sense, although it might lead to those things. Okay, a significant motivation for this step comes from striking similarities between mobile luminous objects and ball lightning characteristics, as indicated in the next section. A second motivation is that the particular ball lightning model we have in mind, which is referring back to this paper that I've painstakingly gone through a little bit of it. A second motivation is that the particular ball lightning model we have in mind incorporates magnetic charge. Magnetic charge, what you mean like the magnetic charge that was claimed in CIA documents when they observed fragments of a spanner that was analysed by them in the 1980s but from John Hutchison. Well, that kind of magnetic charge, the kind of magnetic charge that Solin talks about in his awarded 1992 patent, that magnetic charge. Magnetic charge as an intrinsic feature. You have to have magnetic charge and an intrinsic for this to occur. It is argued below that magnetic charge as incorporated. Oh, didn't we talk about magnetic charge in here? And monopoles. Monopoles are effectively magnetic charge, aren't they? They are the ends of these threads. We've got one magnetic charge up here and another magnetic charge down here. We've seen it all over the Lion reactor. Okay. It is argued below that magnetic charge, as incorporated into the above-cited ball lightning model, can explain the observed axial stability of the mobile luminous objects. So they had to include magnetic charge, which was already in analysis of Hutchison's work from the 1980s, which was already in the Solin patent of 1992, and was very clearly in the rejected US Patent Office patent application of Solin for direct electricity production from the same type of system as his 1992 patent with modifications, and that was in 2001-2002. So here we are in 2009, and they're having to incorporate what people in various places in the world have been saying, and you would pretty much hope that the Department of Energy would know this. So, you know, I wonder if it isn't all 100% known, and what is actually happening is someone comes out with this explanation, and these things exist. These things exist. We don't have physics to explain them, but look, they're there. So what is going on? Something is causing these things to persist for a long period of time. Okay, so all right, and so let's give a little bit more information of what we know to explain this latest observation. Is that what's going on, or do they genuinely not know? Maybe they genuinely don't know. Maybe they genuinely didn't read the work of John Hutchison. I think it would be difficult to be interested in energy in the 1980s and 1990s and not have seen a program referring to John Hutchison's work. I just think it would be very difficult. So, you know, and then who's investigating John Hutchison? Well, it's someone that went to Stanford, you know, was in that kind of area, or the Bay Area, called Ken Shoulders, you know, making these toroidal objects, which were... How is this not mentioning Ken Shoulders' work? It's beyond me. It's just beyond me. Salient aspects of ball lightning for this conversation here. It floats in the air, free of any connection to material objects, thankfully. Obviously too light to be conventional, solid or liquid. But it could be a very thin spherical shell, which is optically thick. Light would not pass through it. Okay. It's sometimes observed in multiples, mutually orbiting each other. Yep, well, we've seen that. It has been observed to roll or bounce along the ground, furnishing further evidence of self-coherence. It is rather rare natural phenomenon, and so far no one has been able to convincingly produce it in the laboratory. I don't think that's true. Maybe it was true in 2009. No, I don't think it was true then either. We wish to emphasize here that we view EL as natural, luminous, physical phenomena that, while unfortunately included in that's Earthlights, the UFO category, has nothing to do with alien spacecraft and the like. Right, so Earthlights are these things that you can see when you look out of the space station, or you look out of like you see these videos of like these things moving across, and they are observed from like video from NASA, from what do we call it, the shuttle program or whatever, and you see these things. These are Earthlights. They are these kind of phenomena, right? So there we go. Okay, so we've talked about the ball lightning model, so we don't have to go into that. But here they extends the model with a little bit more detail. Right, Vorton production. In the case of MLOs, moving luminous objects, it is assumed that the Vorton production process involves field emission. This is one way that Ken Shoulders produced his materials, his EVOs. Two field emission processes may contribute. One, there appear to be sites of steady field emission, which are assumed to be associated with observed stationary points of light in the cavity iris. And two, there are also observed to be bright flashes of duration 1 millisecond, often preceding the appearance of cavity lights. The second category appears to be associated with the explosive destruction of field emission sites. You mean like Leptons by Georgy Messias? When this was made available in 1996 to the West, his 1970s and 1980s research, it's no reason to not include this. Well, in fact, I'm going to read reference 35 because he may have done. He may have even done that. 35. Advanced the net. No, he hasn't. Okay, right. Okay. All right, we're getting to the end. You'll be pleased. Mobile luminous objects, MLOs. Right. So anyway, this is Leptons. This is what Graham Hubler would dismiss at ICCF 23 in China as just Coulombic explosions. It might be just Coulombic explosions, but here in this paper, sponsored by the US Department of Energy, that's published in 2009, these just Coulombic explosions are producing long-lived mobile luminous objects. What do you think about that? The person that was asked in 2000 by the BBC to comment on the Abrahamson-Dennis model of ball lightning. How could you not be aware? How could you not be aware of this work? That just doesn't understand you. You ran the naval labs. Why do you not know that? So here we go. You've got something that's starting to look a bit like the diagrams in the Nevesky paper, where you've got something going this way, and then there's a rotated magnetic axis and magnetic charge in rotated diality plane. So you can start to see the meshing of the two concepts. This is a couple of decades behind, but anyway, we'll get there in the end. Okay, so it's a little bit better. Electric component of rotated charge, magnetic component of rotated charge. Okay. To address these problems and obtain a consistent mathematical description of the diality rotation process, there are at least two possible approaches. One, assume, as Maxwell did, that there is some term missing from the symmetrized Maxwell equations. Or two, assume that there is some new and unrecognized physical process, as was done, for example, to explain the missing energy in beta decay. Right? So the production of a neutrino. Following the latter approach, we postulate that there are new kinds of electromagnetic currents present, which we shall call vacuum currents JV and GV. Very similar concept to the mentioned by Schwerblis and Nevesky. Right? So, assuming that the process of diality rotation generates these new vacuum currents, these new phenomenological vacuum currents, blah, 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 blah. It should be mentioned that ascribing these currents to a vacuum process implies that they do not depend upon ordinary matter to flow. Yes, my friends, 2 decades on, in fact, 21 years on, well, no, 21 years on, from when Schwerblis saw in a Moscow basement the electromagnetic phantom produced by that classified Soviet energetics research. What he is describing in this work is precisely electromagnetic phantom. It should be mentioned that ascribing these currents to a vacuum process implies that they do not depend upon ordinary matter to flow. That is, since the quantum vacuum or Dirac sea is populated at the maximum density allowed by the Pauli exclusion principle, the presence or non-presence of matter is essentially irrelevant. It is completely irrelevant whether there is matter there or not for these pointing vectors, these closed pointing vectors, these closed current flux energy currents to exist. The presence or non-presence of matter is essentially irrelevant. The particle density in the Dirac sea exceeds that of ordinary matter by many orders of magnitude. In looking for a physical basis for these vacuum currents, one can imagine that the quantum vacuum could carry perturbations in the diality reference angles mentioned above as waves in space-time. High frequency gravitational waves. Waves in space-time. Does not need physical matter to support these vacuum currents. One expects these proposed vacuum currents to have physical effects, generating magnetic or electric fields, respectively, as dictated by the generalized and extended Maxwell equations. One expects these proposed vacuum currents to have physical effects. You expect it. You expect it. You know what? Schwerblis saw it in 1988. One expects these proposed vacuum currents to have physical effects, generating Not relevant on any solid matter you can touch, feel, or believe in. Magnetic or electric fields, respectively, as dictated by the generalized and extended Maxwell equations. As described below, detection of these effects should be experimentally accessible. Qualitative description of mobile luminous objects, ball lightning, Earth-like configuration. The oscillating electric charge of the Vorton core will attract or repel electrons and ions according to the common value of theta. In addition, ionization of the neutral atoms entrained in the Vorton core will also be a source of electrons and ions in the core. Thus, in general, mobile luminous objects, ball lightning and earth lights consist of a plasma of Vortons, electrons and ions. Wow, this looks exactly like an exotic vacuum object description, but we've just renamed the things because this is funded by the Department of Energy. I don't know. This is impossible to me that this author could not be aware of Ken Shoulders. He's in the same area. Ken Shoulders is alive. The patents are published. He's publishing. He's going to conferences about energy. It's bizarre. It's bizarre. But if you don't want people to make connections, you have to rename everything every time you talk about it. So it's always not, you can't make connections between things. But is it deliberate, or is it just people independently discovering the same thing? Could this author genuinely have not read the paper of Schwerblis from 1995, or the paper proving this through Maxwell equations, generalized Maxwell equations, that it would produce persistent magnetic or electric fields in 1993, published in the Soviet Union, but then the Russian Federation's long-time electricity peer-reviewed journal. Why would you not be aware of this if you are in this field? I don't know. Is this trying to basically claim credit? Or is this just someone realizing this is the only way it can possibly be and coming to exactly the same conclusion as can be derived from just looking at one sample from John Hutchison? Oh dear. Right. The oscillating electric charge of the Vorton core will attract or repel, blah, blah, blah. Okay. The Vorton core, electromagnetic energy. The NV Vortons of the core are in a state of coherent diality rotation. So basically, however many Vortons there, the whole thing is coherent, right? It is coherent matter reactions. Thus, each of these NV Vortons will have essentially the same electric and magnetic charge components. And the Vorton core will be characterized by a monopole of electromagnetic charge of magnitude blah blah blah. A monopole of electromagnetic charge. Are we there yet? Equilibrium point. We're now in a position to show in lowest order how the diangular and Coulomb energies interact to yield the point of stable equilibrium for the size of the Vorton core. We discussed that in detail. We see the same chart here. We see that the dynamics of Coulomb energy and diality rotation can not only account for the stability of the core in each of the orbiting pair configuration, but also at the same time for the stability of the pair separation distance. And the stable pair separation distance can significantly exceed the size of the Vorton cores. Okay, so we've shown that, and here's some separations. And Ken Shoulders calls this a bead chain, and so forth. Okay. Second, it is natural to suppose that EK could be characterized by a temperature sufficient to lead to visible thermal radiation. One would also expect radiation from the recombination of electrons and ions, as well as from excited ionic and atomic states. Those are the combinations. Blah, 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 blah. Right, just take a couple of points here. So this is in relation to the mobile luminous objects. Stable configurations of multiple mobile luminous objects. Minimization of the total energy of the configuration sets the equilibrium condition for both the mobile luminous objects cores and separation distances between mobile luminous objects. And the stable separation distance can exceed size of the actual objects themselves. And self-coherence, diangular momentum and energy acting through an equilibrium condition furnish the self-coherence forces. Okay. Blah, 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 blah. Oh, there's our Hessdalen lights again. The magnetic field B and vacuum currents. The vacuum currents associated with diality rotation lead to an interesting experimental prediction, which might be called the no eddy current effect. Blah, 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 blah. Here's all the maths to work out what the no eddy current effect is. Blah, 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 blah. As a consequence, the oscillating magnetic field and its associated oscillating vacuum current, GV, resulting from the diality rotation of charge, would penetrate this perfect conductor as though it were not there. What did I just say? What did he just say? He said that because of the way these vacuum currents and the diality rotation occurs, an exotic vacuum object can be configured to such a state that it will walk right through things, even metals. How on earth does this author not know about exotic vacuum objects, Ken Shoulder's work? How on earth? It doesn't matter. He's explained how this structure allows for these things to walk right through solid metals, as it did in the exploding metal foils of Aritzkiev, as it did in many LENR researchers that have seen ball lightning coming, like Matsumoto observed these things coming out of their reactors. Okay, so it creates a no eddy current effect. So it's not heating the material, and it's not producing an eddy current that would then cause it to be deflected, right? You know, Lorentz, whatever, and you know, it's coming to a metal, gets an eddy current, and then it gets rejected by the field it's created. Yeah, this has no eddy current. This allows it to penetrate metals as if it were not there. Let us now consider whether or not the B field and its associated current GV can by the same line of reasoning penetrate a superconductor, which is indeed a perfect conductor. Well, to cut a long story short, not really. The associated current GV will be shunted away by reactionary supercurrents. Thus, one expects that both B and GV will be shunted out of the ends of the cavity, penetrating the vacuum flanges, which are made of normal metal, typically a stainless steel alloy. So, if you wanted to create a craft that could not be damaged by the thing that you want to propel it with, which is this technology, you would need to create a superconducting sheath. Well, how could we do that? Oh, I know, we could cover it with exotic vacuum objects, smaller ones. That would be a superconducting sheath, and that would prevent penetration of the structure that you are going to energize around it to provide the propulsion. Interesting, eh? A prediction of this theory, then, is that an oscillating magnetic field with a fairly low frequency could be detectable outside the cavity when MLOs are visible inside. The no eddy current effect, however, would dictate that a pickup loop would not detect this field. A flux gate magnetometer should be used. A prediction of this theory, then, is that an oscillating magnetic field with a fairly low frequency could be detectable outside the cavity when MLOs are visible inside. The no eddy current effect, however, would dictate that a pickup loop would not detect this field. A flux gate magnetometer should be used. Therefore, I propose that we have to use flux gate magnetometers if we are going to be able to witness this alternating magnetic field on an oscilloscope. That is something that the community needs to try and find a way to come together to deliver that. I put out something earlier today, well, it was earlier today, it was in the middle of the night, but anyway, for people to consider. There are commercial ones that are available, and they are stupid expensive, like $6,000 to $8,000. But I think I think actually this research is worth that. I think it's worth a hell of a lot more than that, but I think it's worth that. Summary and conclusions. In this paper, the properties of mobile luminous objects, as observed, were reviewed. A striking aspect of the mobile luminous objects data was that they performed closed orbits without wall contact for extended periods of time inside a superconducting niobium cavity. A small particle model was described. The small particle model was able to account for important aspects, e.g. radial stability and preference for an elliptical shape of these orbits, but it was asserted that no explanation for the observed axial stability of these orbits was evident. Another important question relative to this data was that the nature of the objects themselves. Analysis based upon the small particle model appears to rule out ordinary matter in its known state. Oh, like exotic objects rather than ordinary objects? Solid, liquid or gas. It's none of these things. And looking to a plasma as the answer leads to an important violation of the virial theorem, i.e. no answer there either. So normal physics cannot do this. The need for proper understanding of these questions leads to the conclusion that the small particle model is incomplete and forms the basis of the argument that the MLO phenomena cannot find an explanation within the realms of established physics. Noting that the qualitative features of MLOs are very much like those of ball lightning and earth lights. A ball lightning model that incorporates electromagnetic charge performing diality rotation was described. It was pointed out that the magnetic charge, intrinsic to this ball lightning model, magnetic charge, what you mean like the magnetic charge that is talked about at the Moscow Nuclear Physics Institute, that was talked about by Hutchison, that was talked about by Solin, that kind of magnetic charge, intrinsic to this ball lightning model, could furnish an axial stabilizing force. In addition, the process of diality rotation gives rise in a natural way to a force that could contain the Coulomb and thermal energies of the MLOs, and hence satisfy the virial theorem. Thus, while MLO, ball lightning, and Earth-light model has the capability of explaining the most perplexing aspects of the MLO data, its foundations reside outside the realm of presently established physics. Let's establish this. In conclusion, in view of the obvious limitations of established physics to explain the data in hand, it is important that as additional cavity lights data becomes available, the exploratory power of the new physics framework offered by the Vorton ball lightning model be further explored. And there we go. That is that. So the key points that come out of this is that a long time after other authors, they are accepting magnetic charge as being absolutely necessary, that there is a magnetic current, and the magnetic current in these structures should lead to the observation of a persistent electric or magnetic field which will be detectable, the magnetic field being detectable by a flux gate magnetometer. And if you build these things big enough, you could imagine that something thousands of kilometers away would, as it's forming and failing, would leave magnetometers in Alaska with a big signal that was recordable, and we need to bear this in mind. So if you combine this work with the work that we have already discussed at length about Zverblis and Nevesky, with the bagels, and with the fact that we've observed these exact structures as witness marks all the way back to 1980 in the work of Bostic and Nardi in their published paper, those marks, and in the work of Matsumoto in his marks, and in the marks that we have observed on the Hutchison samples, and more recently the physical objects. We have a thing. This absolutely has to be it. It has to be it. You can't have the Japanese, the Russians at the highest level, and I believe the Americans at the highest level, all agreeing and then coming to the conclusion that it can only be this, that normal physics cannot explain this, and that there has to be persistent vacuum currents that are not dependent on ordinary matter. Therefore, they could present themselves as EM phantoms. This is what was observed by Zverblis in his experience of the classified energetics research. I believe that through disruptive discharge, as described in the previous paper that I went through in detail, this can be produced technologically and was produced by John Hutchison using the disruptive discharge, but even radioactive sources can do the same thing. But the disruptive discharge generator that John Hutchison produced was the same kind of disruptive discharge generator. It was based on exactly Tesla's one, and the disruptive discharge generator of Tesla was used as his mobile demonstrator of the effects that he could produce. And the fact that Tesla described a vehicle of any weight, of any shape, being able to travel at fantastic speeds in any environmental condition, back in 1911, I think it was, in the Sun, New York, he knew and projected forward the capability of this technology. Did someone develop it? I think so. Do we care? We should care. Is this a natural phenomenon? Yes. Can it cause vacuum decay? I absolutely believe it can, and I believe we have observed that in our experiments. When you see that tungsten or that nickel or that titanium wire being consumed by the ball lightning, okay? When you see these spherical sections eaten out of material instantaneously, I believe that that is because of vacuum decay. When it's at sufficient level, there is nothing that is ordinary matter that can resist this. Nothing. But the thing that's beautiful here is that if we can get a free floating fireball and we get the ball lightning and we can feed it enough electrons to keep it excited, enough matter to keep it excited and keep it stably there, it will act as a current source. And you just need somewhere to dump the current. That's it. You just need somewhere to dump the current. Okay, so you can put that on one side of a battery and then the other side of the battery to the ground, right? And you charge batteries. Okay, or you just run things that need electricity. But this is why I believe PAP needed that thin electric wire connected. And pretty much, I'm pretty sure PAP, for whatever reason, knew a lot of this. He was creating these structures within his reactor. 100% certainly. 100% certainly. Okay, so I'm going to read your comments here. If you've got any questions, now's the time to ask them. Yeah, I'm just looking to see if there's any comments, but you just looks like you've had a fantastic conversation. So this is just wonderful to see real experimentalists, you know, churning over the details. You know, when someone says, I thought about the Hall effect sensor, and you can get ones that go down to 100 microns with you know, some. There's very good ones being made, but he's saying using a flaxgate magnetometer, we shouldn't fight this. I believe you need to use a fluxgate magnetometer. Every experiment you conduct is without a flaxgate magnetometer, in my view, is potentially a waste of your time and is possibly going to depress you, because you may not observe something that may actually be going on. So I might write into the blog the bullet points where I wanted to show the various things that pointed to understanding the bulk structure of these optically thick but thin physical structures that we have observed. I don't like Discord because it's owned. I think it's owned by Microsoft now. Microsoft now. I dislike any system that is, not. You don't own the data particularly. Also from my personal point of view, I already have too many channels to work with, as it stands. So. Obviously, everyone's free to do what they want. I just ask you, this isn't for you to get rich. This is what the planet needs. That is why I'm doing this. You cannot own this. This is boot level. This is root level control of the universe. And do not try and take it too fast. To not try and take it to the max. This will have deep biological effects. This will have disruptive effects to ordinary matter. If I've not made that clear in what I've been saying today, you need to understand that we have observed matter being completely disappeared. Okay? And in that process, if you follow the logic here, it is arguing that some of that matter is converted to high energy positive ions. High energy positive subatomic particles that you have no means to detect that will be shooting out of your reactor, okay, doing things. And obviously the observed strange radiation and coherent matter fragments doing their business with other materials, including you if you're in the target line. So you need to respect this. I think we need to be very cautious with understanding what affects biology to start with. I think that I implore everyone to focus not on the usual things, but focus on what makes a mung bean seed grow faster or slower. And I will do a tutorial maybe this week along with updates. That's what I'll do this week. A tutorial and updates on how to grow your own mung beans very simply and effectively, in a way that you could employ with this technology. Yeah, and the best, most affordable fluxgate magnetometer is the one that was developed by a guy who was a farmer and just an interested person in the UK, and that's been taken over by the guy that runs that website that I gave a link to. I think the best device is the one, well, one of the best devices is the one that I gave a link to also, which cost between, I think, 6,300 euros and 8,000, depending on whether you want a mobile unit or one that attaches to a computer that you might have. I think, once we can, with one device, observe the field and variation, the oscillating field, and the persistence of that oscillating field, and now I'm utterly certain that this is exactly what's going on. Either the Americans were playing catch up with what the Russians were doing, or they independently came to effectively the same conclusion at the highest levels. And I can't believe that that occurred. I'm going to say in a vacuum. No, I can't believe that that occurred without there being some truth to it. And so I believe this is a real thing. It's really weird to think that you can create something that persists in space that doesn't require any interaction with ordinary matter. And it just lets me know that, you know, you are creating something that's an exotic vacuum object. And it kind of gives more granularity and detail to what Ken Shoulders was meaning by exotic vacuum object. These structures, they are a little bit unhinged from ordinary reality. So they can walk right through things. And they are teleporting the material that's contained within them because they just shield its interaction. But you can see kind of how it's shielding its interaction, because it's like, if you can imagine a grid and all of the atoms are on that grid, well, it's kind of like takes those atoms and it rotates those atoms a little bit so that it flies through the gaps in the grid rather than colliding with the vertices on that grid. So you I kind of think of it a bit like that. But because the structures can distort the grid so much, the ordinary matter that sits on that grid fall off. And so they lose their connection with the local Dirac reference frame, and the baryonic matter, or at least some parts of it, just fall apart. Just fall apart. And there we go. Yeah, I will paraphrase because he got it wrong. This is one small step for a man, a giant leap for mankind. He left out the A, I think it was. Therefore, both parts of the sentence meant the same thing. So, you know, if you create, Matsumoto talks about a wormhole. So if you create these two magnetic charges and they have this flux between them, okay, and then you separate them, the flux could be a means by which information, because the flux is incredibly dense, it's kind of like you push this and the other bit moves instantly. Right? So Space Case had this example where he had this Wilmshurst device, and he took one part of the Wilmshurst device with his short-range home phone and was able to communicate over a much greater distance. And it may well be this case that you have a monopole in the distorted physical vacuum and the opposite monopole with the flux loop between, and it's just push-pull, and effectively your this bit of space-time is effectively quantum locked to this bit, and you move them apart, and through this flux loop it basically the communication is instantaneous. So you may be able to use this technology to create communication, for instance, between yourself and a submarine, or yourself and someone in the middle of a mountain, and the communication pathway goes through this filament, which, according to Matsumoto, is down at the Planck's length, so 10 to the minus 33. So it literally will pass through all ordinary matter. So you will have and the communication will only be possible between the two areas, right? So basically, unless you are at the end where you've got the device that's going to be linked to the other side, there will be no way of intercepting the signal, because it goes through this thing that's uninterceptable. Yeah, this is quantum entanglement, yeah. Now the question is, if you created a ball where you had 100 of these things or 1,000,000 of these things and then took each of those away, could each of those provide a communication between each of all of the others? And I'm going to do a little bit of crazy here to close out. And when Jesus was giving the showbread and the red wine is known for having monoatomics in it, and showbread is meant to have been produced with monoatomic elements. And if the monoatomics come out of the same system, and this is the reason for my ring being made out of a single gold nugget, and my wife's too, the matter is entangled. And so by giving all of the disciples his body and the blood, you are binding those together across space-time. So even when Jesus died, he was able to communicate with the disciples, and the disciples were able to communicate with each other. They become one body, one spirit. And in part, this is, in my view, the science behind communion, and why you kind of have to go through a process to become confirmed, such that you believe and accept in that. And if you have a community in your church, let's say, and you are all given some red wine from the same bottle, that has, in my view, the monatomics, if they've been generated in the same plant, in the same organ of that plant, they will be entangled to a degree. And therefore, over a period of time, the community becomes bound by the monatomic coherence. And that will persist because the monatomics don't react in normal ways that chemistry reacts. Then the community becomes stronger and stronger over time through the process of communion. And I think Jesus knew this technology and was willing to make a thing of it, being very critical to the kind of like being able to share information. I think it's sad that these kind of things have been broken down. But I do like to think that, you know, one of the closest knit family societies in the world is actually the Italian, North Italy particularly, and they will quite often have family meals together, and quite typically they will have red wine with their meal. It doesn't need to be a lot. Like when you have communion, you're just taking a little sip. Obviously, the bread is just a wafer, a starch wafer now, and it's meaningless compared to the monatomic containing showbread. But yeah, so that's my little bit of crazy for tonight. This is not crazy. This is how it is. This is it. This is how you can walk on water. This is how you can clone things. This is how you can create the ability to, you know, push oceans aside and sadly destroy very large structures. And it is the occult technology. It will be the technology that is the ultimate technology that all sentient beings will discover at any point in our universe. There might be slightly different parameters in different universes outside of our bubble, but in this universe, there's no other more root level technology that you can use. As Ken Scholder said in 2010, if there's something you would want doing well, this is probably the technology that would do it. As a bonus, we discovered that probably ball lightning core temperature without excitation is around the temperature of that calculated in this, which is around about 130 degrees. And that was just a real special moment for me in this presentation today. Yeah, I believe that I believe that SCOBY, and I did a presentation. You can go and have a look on the MFMP YouTube channel in reference to Alakorlanova and Vysotsky's radiation remediation technology using syntrophic colonies of yeast and methogenic sea ooze bacteria. I think SCOBYs are also producing nascent elements. I think those people that are drinking kombucha are drinking something that really, really does have huge health benefits. I don't think for the level of sensitivity and the granularity, the resolution and the response time, I don't think there's anything that's a good substitute for fluxgate magnetometers in this case. Of course, if you've got very, very, very big exotic vacuum objects chewing up a very large chunk of landscape, as happened in the event, you can use normal magnetometers used to measure the Earth's magnetic field in Alaska, and you can see very large signal variations on them as you're doing your experiments. So you could maybe, if you were stupid enough to go ahead and take this to the max and I don't know. Dematerialize a very large building, for instance, you could go and ask the magnetometers in your local region of the tundra to tell us, did you see any signal when I made this building disappear? You may say that, Jeremy Godoy, but I can't possibly comment. No, I think the way this is going to go, Space Case, is ideally someone would have access to or give access to the Swiss-made, unbelievably fantastic three-axis high frequency fluxgate magnetometer, which starts at €6,300. And then once that's proven, you would find out if you could see the same effect with the cheap, like €60 device with some control electronics and an oscilloscope. And then you would bring that down to something people could build with a piece of ferrite core and a couple of coil windings and a signal generator and an oscilloscope, and demonstrate the same effect with something that could be built in a classroom in a normal class. That's ideally the process you would go through. So sometimes you have to see the effect, verify that it can be observed with less capable equipment, and move down the line. But if you're starting with less capable equipment, you go, well, I didn't see anything. And it's like, well, you're never going to see anything, are you? Or you may never see anything, or you might need to be fine-tuning something. Okay, so this was Ode, Light and Leptons. I've finally been able to do what I wanted to do a long time ago and describe how this converts matter into light and leptons. And I described, starting with the work of Bogdanovich at the Moscow Nuclear Physics Institute, and the observations, just briefly overviewed here, but I will point to the various articles that I've published in the past on these various subjects so that you can explore them in deep detail to understand where I'm coming from, how you could end up with self-organized structures, and using the paper that was published in 1994, we know that what he's called this author here, called David Freiberger, how he is saying that the diality rotation, which is this poloidal and toroidal motion that you get with these structures, allows for self-organization of these structures. And this is probably wrong. I think probably the toroids need to be much closer to the center here, because the distance between them is much larger, and then I think we'll end up with something that's closer to what is actually observed. And I actually made a rough model in Photoshop that kind of in a way matched what was observed by Bogdanovich et al. So you've got your tori there, but like I say, these need to be smaller. These are tori, and there's the central focal spots, and then this is the combination, and then by fuzzing it and then distorting it, you end up with something that's not too dissimilar to that observed by the work of Bogdanovich. And yeah, so we verified why this can be a current source. So you can imagine you've got your ball lightning here, and it's just consuming matter, and it's chucking out a load of positive particles so far away that in the near field it has just a whole bunch of electric charge, and you can extract that charge to power your universe that you need to. And as the Russians said in that CIA declassified document, you can take iron and you can get the hidden energy within the matter, and it is the same process as cold fusion. And using 1 kilo of iron, that is quite sufficient to get you to Alpha Centauri in 6 years, and back in another 6 years. So that's 12 years, using the energy contained within 1 kilo of iron. And the process by which you gain the energy will also allow you to produce propulsion. And so if you can imagine one of these things that's consuming matter and then throwing the positive particles out the back, you could basically have a situation where you have iron, you're feeding it, and it's throwing the remainder positive charges out at relativistic speed. So that is your propulsion system, and it is also the energy system. So there we go. That is that 1992 classified document, I think fully demystified. We can get, with this technology, to the nearest solar system, which has potentially habitable planets, Alpha Centauri, in 6 years. And that is a time which is a reasonable amount of time to do. Yes, and with an Evo skin, quite possibly much, much faster. Okay, so that is it for me tonight. It is 2:40 here. I thank all of the experimentalists that are doing such a fantastic job in taking these concepts forward. Obviously, this would never have been possible without those people doing things like the Vega experiment. So thank you particularly to David Boutillier and Hank Uren. And also, I must thank absolutely profusely John Hutchison. We would never be where we are, or without the Lion reactor. And all of those people that have shared their data, both in patents and other data and so forth, but also the supporters. Today, I passed a particular milestone of 400 subscribers to Remote View, so thank you. And thank you to those that actually pay for subscription. That really helps me justify this to my family. And so that's really, really helpful. I'm going to be asking a question of those people who support me in that way moving forward. But I will share all of the images from this little puppy in the blog over the next couple of days, and also potentially some variations. And I think also the work done by Peter S. This week on building a bagel parametric system using OpenSCAD is a huge contribution, because not necessarily if you're going to actually build them, but a way to understand in physical terms what these things should look like when they're organized with a certain number of coils and turns and stuff, and gives you an idea of the amount of material that needs to be used and stuff. So it's these kind of contributions. So I hope maybe that work will help inform fusion. Fractal woman on looking at making a electrodynamical model that predicts the fields that are involved here, and maybe with this work it can also be honed, so we can bring the Russian and the American work together to deliver a very good model of where these phantom fields are created with respect to the coils, and so we can understand where the safe zone is around these devices, or what the field of influence is. I think we can pretty much guess. I think I wouldn't like to be within the ball hole field. So if you remember, we had this spherical structure, one of these crenellated iron spheres, a small one about 3.8 microns across, in the diamagnetic diamagnetic zinc oxide and copper oxides, and it had this fall off. I would not like to be in that field, so I would suggest that you can use it as a first approximation. You could use that as a guide as to how close you should be to an active coil for any reasonable length of time, relative to that structure. So if you look at that's 3 point whatever microns across, and it was a much larger field over which the influence goes. So I just wouldn't want to be working in that space for long periods of time. On the plus side, that if it's having a positive effect, then that it might mean that one of these coils could actually be placed in a large vegetable bed and actually stimulate the growth of a large area of vegetables or fruits or stuff. So, we need to understand that. Okay, so thank you very much. I think we're at the end of the beginning here, in terms of understanding the vacuum engineering aspects of this, which is getting close to concluding the more sciencey aspects of O-Day, and we're more really. This is really coming to the end of Goal 2 of the Martin Fleischmann Memorial Project. The goal 3 is really to promote and educate and see uptake of all of the various implementations of what this technology can deliver. So I think we're going to be changing phase moving into the coming years. You guys are right. You're right at the forefront of this, and there's so much low-hanging fruit. There's so much low-hanging fruit, because most of the trained scientists in the world do not even believe or even consider that this is anything like a possibility. Yet at the highest levels, they are knowing that this is a possibility. And do you think that they are researching this at the Moscow Nuclear Physics Institute, or in the SLAC in Stanford, in Menlo Park? Do you think they are researching this over decade, because they think it's just hogwash? Do you think that that's what they're doing? These people are dedicating the vast majority of their intellectual lives to nonsense. Do you think that's what they're doing? No, I don't think that's what they're doing. And this can offer a solution to most of the world's problems, if worked with respect, because it's the root level of nature. It's the boot level of the universe, and we are at the dawn of a new dawn for Corky. We're at the new dawn of an old age. And with that, I'll say thank you very much. Good night. Buenas noches. Dobro noc. Buenas tardes.